Welcome, everyone. This is Mike Gibbs, and welcome back to week 2 of our free AWS Solutions Architect Bootcamp. And this is the Go Cloud Careers AWS Certified Solutions Architect 2024 program to help you pass that AWS Solutions Architect Associate Certification, otherwise known as the exam SAA-C03. So we've had a fun week, or at least I had fun. I got to speak with people that were all over the world. We've had lots of interactions so far, and we're now here for week 2. So we're going to continue where we left off, but in case you're new to us, in case you've just joined us, I'll go through a few housekeeping events. So if you've just joined us or just saw this 6th video for the first time, we have 5 more days of videos for you to go back for to make sure you truly understand this AWS Solutions Architect Associate certification. So go back. You can watch the first 2 weeks anytime you want. Each day will, for the most part, stand alone. So you could start now and go back and watch those individual things and be just fine. Because we're basically spending 2 weeks for 3 hours a day just covering the core concepts, we also want to make sure you have the opportunity to get hands-on if you're going to be in a hands-on career like a cloud engineer or a cloud admin or a DevOps engineer. We want you to get that hands-on. So we have about 40 plus hands-on labs for you to do. You can sign up for them. The link is in the description of this video, and my team will pop it in the chat box as well. It's completely free. Go after it and go do them on your own time. I also wanted to say from a housekeeping perspective that we've written a document on how you should approach your certifications. It saddens me when I see people that have got 10 certifications, but they all show me that I can't hire the person. But if I see 2 or 3 big certifications that point one person down that shows focus and competency, I'm much more inclined to interview them. And they're much more inclined to actually have the right skills in their careers. So we have a free guide on how to get the right certifications and the certifications for your goals. So please download that. It's completely free. While we're at it, in the chat box, we've got a free ebook on how to get your first cloud architect or solutions architect job, and it's free. So go get it. And we're going to have fun today. So tell me where you're from. I see some Seattles. I know some of you are in certain places. I see Bo, Cameroon, which I love. I see people that are in Colorado. I see New Jersey. I see Canada with Renato. Renato, it's always good seeing you. I know Tyrone from our team is in Cape Town, South Africa. I know Eddie from our team is here in Bamenda. And I also know that Alonzo from our team is in Katy, Texas. Where are you from? Or where are you at today? Or maybe a little of both. I also want to know that so let me know that. And also, while we're at it, I want to know that you are awake, you are alert, and you are oriented. I'm a medical person, and that's just one of those questions we always ask before we start to make sure everybody's there. So if you are, and you're hearing this and you're listening, give me a hashtag AWS-SAA, hashtag AWS Alpha Whiskey Sierra Sierra Alpha Alpha. Sorry, I was going to go to the exam number there. So wonderful, wonderful, wonderful. Now I will see those pop in, and we will get to the content. And if you're new and you're just catching this or you've been here, invite a friend. It's completely free. Maryland, I saw Pennsylvania. I lived in Pennsylvania there for a little while. Actually, like 20 years. Okay, I'm seeing it. It's almost, the hashtag is almost there, so we're good to go. So we will begin. So if you'll recall, last week on Friday, what we actually did was the following. We talked about at the end of the day, identity and access management. And if you haven't been here, we talked about identity and access management, which really is authentication. Who are you or who you to claim to be? So in other words, if Cindy knocks at the door, I know it's Cindy, I might be willing to let her in. But if somebody knocks at the door and it's not Cindy, maybe it's Sally, and I don't know Sally, and Sally's pretending to be Cindy, if I know it's not Cindy, I won't let her in. Cindy's my cat, and she walks in and out of the house all day long. So authorization is what are you allowed to do? So do you have the privileges to access something? So, that's the authentication piece of it. I'm sorry, the authorization. Authentication is who are you? Authorization or what are you allowed to do? Are you allowed to access the whole house? Are you allowed to access all the systems or just a subset of them? And then accounting is keeping track of what you've done. So go back and see, we talked a lot about role-based access control and other things and federated identity access management. I thought it was kind of fun. Token services we talked about, but today we're going to talk about creating and the identity and access management policies. So when it comes to this, you're going to have a few options in how you do this. But the IAM policy is going to be the policy that's created to allow it to determine who users are, what they're allowed to access, and keep track of it. So I talked last week about when you create an IAM policy, you can get very specific, and you're going to assign permissions to specific resources or all of them. And when we write these policies or create these policies, we want to provide access to the specific resources that we need and not to the resources that you don't need. That's the principle of least privilege. And I also talked about when you provide access to a specific resource, you do it based upon the Amazon resource name. And we walked through it last week where it was that ARN colon, and we walked through so you could see what they looked like. Now, you could, instead of accessing one specific thing, put what's called a asterisk or a wildcard, kind of those Boolean expressions, if you will, or regular expressions, if you will. And the wildcard means anything. So you could do that. Basically, you could permit everything, but why would you permit anything when it comes to security? So there's two main policies around, and they're going to be AWS Managed Policies and Customer Managed Policies. So let's talk about an AWS Managed Policy. When you deal with any type of vendor's identity and access management system, chances are they've already made pre-made roles for you based upon common business use cases. So there'll be a use case for, say, a systems administrator, or a use case for this kind of user versus that kind of user. And you can use the standard policies that were created by your identity provider. And if you're going to be using the AWS system, you can easily use the AWS Managed Policy. And they're optimized for common use cases. There's typically two major predefined roles. And there's administrator, which can access everything and do everything. And then there's the power user, who can basically do everything, but they don't have access to identity and access management systems or organizations, which are a way to basically divide an account into multiple accounts and then use IAM between them. There's a lot better ways to secure your data in between organizations than just identity and access management. But some of them get expensive to use, and some add some complexity. So it's a way that you can segment your system if we talk about organizations. So administrator, everything. Power user, everything but IAM or anything that would be IAM based, like AWS organizations. So there's an alternative. And regarding managed policies, what you realistically do is you're going to sign into the IAM console with a user account and administrator privileges. And from there, in the navigation pane, you'll just choose policies. And then what you'll see is there's a list of AWS managed policies, and they're simple to use, updated by AWS, and it can avoid, major configuration errors if you're not very skilled. And it's going to work for most use cases anyway. Now, what if you need a custom policy and you've got users that need lots of different specificity, or maybe you have something called separation of duties where you have a team of people and each one of them can only do certain things separately, and that way one person can't do too much damage if they're a problem, so which you may see in high security environments. So there you're going to need a customer managed policy, and this is a policy that's going to be created and managed by the company for their own unique needs and their own account. The policies the customer create will not be visible outside the organization, and they're going to be custom tailored, so they'll be attached inside of the AWS account. So how do you create a customer managed policy? Well, if you've got someone great that's good at programming, they can just write their own policy in JSON. It's easy. It's no big deal. But what if don't have someone that's familiar or very good with JSON? You got a couple options. One is you can use the AWS policy generator, and it's a web page where you go to and it asks you specific questions and it generates a policy for you. The alternative is you can basically use an AWS policy and open it up and edit it to tune it to your needs. So that's how you would do something. Policy generator is a pretty easy kind of page to go to. I'll show you what it looks like. So you go to this policy generator, and basically you tell it what kind of policy you want. And you go allowing something or denying something. That's your effect. To which AWS service, which is where I talked about that Amazon resource name. And what do you want it to do? What's the action? So pretty easy, pretty simple. They do try to make it relatively easy for you. So that's, how you would create the policy. So you've created the policies. How do you apply them? And typically speaking with AIM, you create a policy and then you either add users to the groups or what have you, or you apply a policy to a subset of users or what have you. So how does it work here? So for the policy to work after you've created it, it needs to be associated with something called an IAM principal. And an IAM principal is anything that can use the Identity Access Management System. Now, you can apply this to a person like Cindy. You could give a special policy direct to Cindy and only Cindy. And that's totally fine. But let's say you've got 1.5 million people working for you like Amazon. It's going to be pretty hard to create too many of those policies and give them to just one person. You may want to do it for the C-suite, a very small number of people or a few special scientists that are there. But you're not going to do it for most. So for most, you're going to divide it into this role-based access control, finance users, systems administrators, what have you. And you'll apply that policy specifically to the groups of individuals or systems that you would use. And that way, and in role-based access control, I'd say group, systems admins. And then I would add the users, Billy, Sally, Joey, Hal, they get all added to the group. That's role-based access control. So another diagram we do, I hope this kind of makes it easier. So you may have an account. It could be the Cindy the cat account. And under the Cindy the cat account, assume she's a famous cat and she's got her own website and she's got her own business and she's selling memorabilia and tuna. I got a very innovative cat, who knows? So Cindy would be the owner of the account. She may have some administrators, some software engineers making Cindy the cat websites. They may have another people that are actually testing the websites, maybe a group of cats that are trying to see if the cats like the website and they're going to be interested in using their paws to click buy on the keyboard, somehow figure out how to manipulate their owners to get their credit card from them. It's not that hard. A cat can get anything at once just by looking at you. So there's that. So we might create this big account. Then we've got our groups and then we add users to the group. So the testers are Mark, Joe, and Ben, and they're added to the group test, and test has its own unique policy that's applied to it. Likewise, the developers, would be Dave, Jake, and Emma, and they will get the policies that you assign to the group developers. And the group admins, John and Grace, they get admin policy or what they need to do their job. And the key to remember here is never give more privileges than are necessary for people to do their job. So what other ways can we improve our identity and access management system? Well, a username and password is not the best. And, it can be broken with a brute force attack or a dictionary attack. And, the better computers we have, the faster it is to break passwords. So typically speaking, a two-factor authentication is going to be better. And we should use two-factor authentication to secure our IAM accounts whenever possible. Two-factor is something you have, typically speaking, and something you know. So if you want to pull money out of the bank and you get your ATM card out and you stick it in the cash machine, you have the card, right? That's something you have. Something you know is your PIN number. So somebody steals your card and they don't have your PIN number, they can't access your account. Something you have, something you know, two-factor authentication. Now, two-factor authentication can be done a lot of ways. It can be done typically with a one-time password that's going to change every few seconds. And there's commercial things that are out there where basically you see it, the key will be a key fob and it'll constantly give you a one-time password. You can also use things like a Google Authenticator app where basically you give it a seed and then it will create the it will know exactly what kind of one-time passwords we're going to create based upon the seed, and it'll change periodically every few seconds. So I'm sure you guys deal with this every day, but this is called multi-factor authentication. Try to log into your console. It sends you a challenge or sends you a text or something like that. And then you provide your one-time password, and Bob's your uncle. You have access to the system, assuming you've got the right password. Done it, and it is simple. So talk a little bit more about identity federation. It's not going to make sense in an enterprise environment for someone to be creating IAM accounts in AWS and then have that company create IAM accounts for Active Directory for all the systems to access the systems which they're typically using. And then another IAM system, maybe for this system and that system and the other system. So what organizations do is they create what's called identity federations. And they store all their identities in a single place. Usually Microsoft Active Directory in the enterprise. Now, there are other ways you can do this as well, which we'll talk about in a minute. But the key components of an identity federation are an identity. That's the user, like Cindy the cat. The identity store, which is where the identities are stored. Typically, Microsoft AD in the enterprise environment. But in the non-enterprise environment, you ever see somebody say log in with Facebook or log in with your Google account or your LinkedIn account or your Apple account? They are an identity store. So identity is the user, like Cindy the cat. An identity store is where the identities are actually stored. And then as part of identity federations, we also have to have an identity broker. And what is this? It's going to be that thing that goes in between the AWS IAM, and it's going to go to that Microsoft Active Directory or Facebook or what have you. And then it's going to come in and provide temporary credentials to access those AWS resources. So users, Cindy the cat, identity store, where Cindy the cat's access information and her pod directory is sitting inside of Microsoft Active Directory. And the identity broker is going to go check with that Active Directory and then provide whatever's necessary to access the AWS system. So what's really going on under the hood when you try to make this happen? So the user is going to log into their identity broker with their corporate credentials. It's going to feel very familiar, like when they normally log into work each day. Now that identity provider will basically authenticate the user, and it's going to be based against that, typically an LDAP-based identity store that they have. The identity provider will generate something called the SAML assertion, which is going to have all the required user information, and it will send that assertion to the identity broker. Then the identity broker is going to get that SAML assertion, and it's going to call the assume role, the SAML, and that's going to hit the AWS Security Token Systems API. And it will pass that SAML assertion onto the role for the whatever is needed to be assumed. And then if the API response is going to be successful, it'll issue temporary AWS security credentials with the appropriate permissions. And then you've got those temporary credentials. The client application can perform whatever it needs to or wants to on AWS. So identity federations means scalability, because identity is that last line of defense. I mean, don't want you thinking that identity and access management is really good enough security in and of itself. And I want you to think about it. Identity and access management is someone knocking on your door that's saying, I'm here. So if you think about that being enough security, it's not. Wouldn't it be better to have a giant, 100-foot fence around the building, and then maybe a moat that's filled with sharks and alligators and scary things, and then maybe another something to protect your house long before people could knock on your door, if you're truly building security? And in cybersecurity, we do the equivalent of these giant walls. You could call it a firewall, and a moat would be like an IDS IP, and I would be in a next generation firewall with the intrusion detection, intrusion prevention capabilities. We might use a network-based IDS IPS system behind those firewalls, which is like having guards behind them. But there's the point. Identity is not enough security, but it is part of security, and it matters a lot. But it's not going to scale if you've got users that have to click on everything. So federations are going to be the way to go. And the way it works is there's what's called a trust relationship between AWS and the identity provider. How does that work? What do you mean by a trust relationship? So Alonzo works for me, with me at our company. He's awesome. I trust Alonzo. So if Alonzo says, Mike, I heard this, or I did this, I trust him. And then I might tell someone else on my team, Alonzo saw this, go act on it. And they'd see yourself, and I say, I don't care. Alonzo told me, and I trusted him. So that is a trust relationship. And that's what's going on with the identity and access management system. If you say that this is a trusted Active Directory, AWS will believe you. So there's going to be a connection that needs to be made between these two providers. And that connection is going to be either made with an OpenID Connect or something called Security Assertion Markup Language 2.0. SAML is typically what you're usually dealing with. And that external identity provider can be anybody you choose it to be. You could choose to trust Google. You could choose to trust Amazon. You could choose to trust Facebook or Apple or Twitter or LinkedIn. That is up to you. There are lots of identity providers that are out there. So with this federated environment, AWS Identity and Access Management functions are done and performed by the identity provider. The user will attempt authentication. They will go to that identity provider, and then the identity provider will get the IAM authentication, give the IAM authentications and the privileges to the user. So gives you scalability. Now imagine connecting with 3 different clouds. Imagine connecting with network devices that are used for remote access VPNs. Imagine you've got users and accounts with third-party providers. This is why people need some form of federated identity access management system. Here's another thing to think about. And in some ways, this enhances security, and in some ways, this reduces security. Single sign-on. And this is something we typically do with federated environment. In a single sign-on, it's an authentication method that's used to securely authenticate users to multiple things by logging in once. So AWS single sign-on is a service that will let you sign in one place and then access a lot of things. So sign in on that Windows server and then access anything you want inside of AWS. Typically used there. So why do I say it can enhance security? Well, if you've got too many sign-ons and you force passwords that are too complicated, what you see is users will effectively put little sticky notes with passwords on their desk. Sadly, I've seen this in way too many high security enterprises. So that's going to be a backdoor. But it's just so you want to make it easy for your people to sign in and use good secure passwords. So if they have less of them to remember, you're good. Here's the problem with single sign-on. Get access to that compromised account or password. Now you've got access to everything. So it's a trade. Everything in architecture is what do I gain versus what do I lose? Is it better based upon the business needs or is it better based upon this? So architecture is never really a technology conversation. It gets to technology, but it's all about which has a bigger impact on the business in which way, shape, or form. So this is what it's going to look like. Basically, the company is going to have their on-premise Microsoft Active Directory system for IAM. You know, you connect in the single sign-on environment, and now you can access the systems on AWS because AWS trusted your Microsoft Open-Premise Active Directory service. And then you told your Active Directory service to trust that AWS IAM, and therefore the trust works, and therefore this single sign-on can work by logging into one system and be given access to another. Oops. All right, so next, let's talk about Amazon Cognito. And Amazon Cognito is going to be a managed service that's provided by AWS that enables you to add authentication, authorization, and user management, for the most part, to your web and mobile applications. And it's going to make it relatively quick and easy. So Cognito is going to support sign-in with all your identity providers using SAML 2.0 and your federated identity providers. And it's going to enable you to have an easy approach to the system. And what you're going to see is the user is going to access the system. They're going to go to that Cognito user pool and they're going to get there. They're going to authenticate and say, I am Cindy the cat. And yes, this is my paw print. So you verified me. And then Cindy the cat's going to be given tokens from the Cognito user pool. Then Cindy will use that token that she got, which she provided, they say authenticated her baby or paw print. She'll give it to Cognito and then she'll have access back to pretty much any AWS service she's allowed to. So that's going to be the way Cognito works. So let's talk about some features of Cognito. It lets you set up a user directory for, say, single sign-on. And because it enables that, and it's a managed service to help you with these types of sign-on systems and identities, what happens is you're going to have multi-factor authentication, account recovery, those types of things. You're going to be able to create what's called identity pools. And these are really federated identities. So It'll enable you to grant users access to certain AWS services. And users can be authenticated via identity providers like a Facebook or a Google or SAML into an Active Directory. Now, Cognito is pretty robust. So it connects to your identity providers, your big ones like Facebook and Google, but also Active Directory. It allows for multi-factor authentication. It provides just use temporary tokens using a secure token service so that you're getting a token versus a password and tokens expire. So should a hacker get access to a token, the token's length and how long that hacker will have access will be very minimal because the token will expire unless you chose a long time. Cognito gives you the ability to really customize that user interface, and you can store user profiles and their attributes securely and simply. So, some key things to think about is we have to create these user pools, and users are going to sign up for the application, potentially using email or a phone number or an identity provider. The users are going to be able to sign into these user pools using their credentials, and Cognito will handle the authentication process. From a user management perspective, under user pools, you can add and manage user accounts, forms of verification, password recovery, and profile updates. Now, let's talk about identity pools. And these are where, so federated identities, this is where it's going to authenticate users via external identity providers. And it's also under the identity provider is going to provide these temporary tokens. And it's going to issue temporary AWS credentials to any user that's authenticated through the system, giving them access to AWS. But it's a token, not a password. So how do you set this up? You create a user pool in the Amazon Cognito console. And you'll click that user pool and you'll name the pool. And then you'll configure the full settings. What kind of attributes do you want? Do you want multi-factor authentication? Do you not? And then you review and create the user pool. Then you have to create the client app. So after the user pool, you have to create the app that's going to generate the client's credentials. You'll have to configure the settings for this, how you want the application to flow, for example, when you want the tokens to refresh or expire. And then you're going to integrate that into your identity provider. So the app can actually be integrated in the provider, so of course it can be authenticated. Then you're going to create an identity pool in Cognito, and that'll be in the identity pool selection, and you'll create one. You'll link that identity pool to your user pool and any other identity providers you want. You'll configure those IAM roles for authenticated and unauthenticated users, and then you integrate it with your application, typically via Cognito software development kit. So think to do this. And here's where you're going to implement your sign up, your sign in, and even your user management features. Okay, so let's talk about Actually, let's take a few minutes to see if there's any questions, and then we're going to get into Microsoft Active Directory. And if you have some questions, Tyrone will pop them in the chat box for me. And if you don't, we'll keep going, and I'm happy to keep going. I'm actually going to try to make sure that we go, but maybe if we go a few minutes each day, I'm going to try and finish by Thursday this week. By 5 p.m. instead of running all the way through Friday. I'm going to try, but if you got lots of questions along the way, we'll keep going. How to recover lost browser bookmarks after running an AWS AMI, patching and reboot of EC2 instances if those bookmarks get lost accidentally. So I'm a little confused with the way you're asking what you're actually asking, but typically speaking, you would restore your backups from the snapshot, log into your browser, make sure if I understand what you're asking correctly, and then you'll click for your browser's backup files, and you'd use your data recovery tools. Typically speaking, if you're trying to deal with browser, but you might actually be asking something else. You might also be asking, okay, you changed the system, and you've got these systems you've been using these systems for a while, and then potentially they've come up with a new IP address, and now you've got them stored as an old system that doesn't exist anymore. And that would be you and your end browser kind of doing that. So I'm not sure what you're actually asking. AWS provides its own policy. Can we also create a customized policy? Absolutely. We talked about how you could use an AWS managed policy, and we also talked about how you could create your own policy. We talked about how you could just write it in JSON. We also talked about how you could go to the AWS Policy Center and create a customized policy there. We also discussed how you could take an AWS managed policy, bring that into an editor, and then tailor that to make it your own policy. So absolutely you can. You may not have been here when we talked about it, and that happens all the time. Hi, Mike. You talked about SAML when explaining the concept of federation. Please, how does OAuth tie up with this? So, OAuth is typically used for authorization, allowing third party access to user data and sharing passwords. It can complement or work with SAML in that it provides secure access to resources across different systems. So, SAML is kind of the language which this could actually be done. But there is that open ID as well. But OAuth is much more for authorization and authorization into another system. So I hope that answers your question there, Tundi. Like in case you have 1,000 users, okay, so a small number for generally speaking, how can you add the users to a group created by IAM? Is it done manually by the root user of the? Okay, that's a good question. So I see what you're actually here. So let's say I had a bunch of users. How do you add users to the groups created by IAM? Well, users are typically added to the group manually. So you will create the user. I'm sorry, you will create the group. So you will create the group cats, and then you'll add the cats that you want into that cat group. So typically in IAM systems, I will say this, for the most part, you're going to be using Active Directory for these things or federating into them. And that's typically how that's done on Active Directory and most other identity managed providers. You create the group, you assign permissions to the group or the number of groups you have, and then you add the users to the group. Can you relate single sign-on with the PAM solutions? That's a good question there. So single sign-on is sign in once, and they get access to another things. Privilege access management controls manage access to the resources. So yeah, you're going to want to use something like this together at the same time. Definitely single sign-on will help you log in once and access to the other systems, but you're going to have to track it and how much they've done. So yes, that's important. Now, when you're dealing with privileged accounts or accounts that have access to more stuff, that's where you're going to really want to pull in extra auditing and extra monitoring of those accounts. And that's where those privileged account management controls are really going to help. So yeah, you want to use both. Good thinking. Can Amazon Cognito get turned into an incognito mode automatically? Okay, so now I think I understand why I'm having a hard time with the questions. Because we're talking in one case about an identity provider, and you're actually trying to relate that on the browsers of the end client device. So these are going to be two different systems, and that's why I didn't understand the first one. So Amazon Cognito is not going to be naturally able to turn into an incognito browser mode, because Cognito is is a system itself, and your browser is a totally different system. So it's not going to have anything related to Amazon Cognito. Browser is what the user accesses to the system. And that's, an interesting thing that I tend to see with a lot of people as they're new to tech, where the stuff sort of is. So for people that are not familiar with networking, they typically don't realize that if we go to the cloud, we're going to have a wide area network connection to the cloud. And that's how you access the cloud securely through your wide area network. And internet is, public stuff with public addresses and lots of hackers. And inside of your network is typically where your users are. So that's intranet. Internet is anytime you go on the internet. And then, where the client is, that's the other thing that is kind of tricky. And because a lot of us are used to running systems on our desktop. And in this case, it could be a client server environment. You can have stuff that's thousands of miles away. And what you do in your system is access something that's being done realistically somewhere else and just rendered locally on your system. So that is our last question, and we will go back to the content. And if we need to, we'll obviously answer the questions we did. I want to make sure everybody understands where we're headed. To make sure you're awake, alert, and oriented, please give me a hashtag AWS-SAA. If you're having a good time, if you're learning something, please like the video, subscribe to the channel, and hit the bell to be notified of new videos. And please invite others to see our free training. We've covered a lot of stuff in the last 2 weeks. We're going to our second week. So let's talk about Microsoft Active Directory. And this is a very important concept. It's going to be everywhere. So Active Directory is a directory service that Microsoft created, and they created it for Windows domains. And, in the end of the day, your workers are typically on Windows systems and your servers are typically on Linux systems. But, for the applications businesses need to run, it's not like most people could run around with Linux desktops. I mean, I wish they could. I love Linux, but that's not the case. You're not going to run your business application. You're not going to run your video editing application. You're not going to use your marketing graphics applications. You're not going to use a lot of these systems on Linux as much as I like it. So because Windows is the end user in the majority of enterprises, we have to be really good at understanding how these systems work. So Microsoft developed a directory service for logging in and accessing Windows systems. And if an enterprise has 100,000 users, probably 80,000 of them are using Windows. So they need to manage these systems very carefully. So Active Directory is really a cornerstone of enterprise IT infrastructure. And it has a whole lot of services related to identity and access management. Now, when we deal with Microsoft Active Directory, we've got a couple of things to think about. We've got a domain. And a domain is going to be a logical grouping of, say, network objects, which means computers, users, devices that are going to be inside of that same Active Directory database. And in order to control this, everything needs a control plane. We have what's called domain controllers. And these are the servers that are going to respond to security authorization requests, like when you want to log in, that sort of thing. And they also hold the database. And they manage any changes that are there. So you've got your domain, the entire area. Your domain controllers are the big brains of the system, which are big Windows servers typically. Some components of Active Directory, and this has been going on for a long time, we have this concept of a forest. And the top level container in an Active Directory configuration, and it's going to typically contain one or domains. So you can almost think of a forest as a security boundary. And we have the concept of a tree. So if the forest is going to be the top level container that may or have one or more domains in it, we're going to look at the tree itself as a collection of one or domains that are going to share a contiguous namespace. So gocloudcareers.com or something like that. But they have these namespaces that are created in there. And what happens is domains within a tree, they're going to be linked to each other via that transitive trust policy hierarchy, which, if this one trusts this one, then it's okay. Now, we've also have the components of what's called an organizational unit. And they're going to be containers inside of the domain that are going to hold users, groups, computers, and other organizational units. And it's going to help by managing and organizing the domain effectively. Now, because Microsoft's Active Directory is a database, for the most part, that's got all these identities and records in there, we need to have some form of a schema. And that's going to be a set of definitions for all of the objects and the type of information the directory is going to contain. It'll define which objects can exist in the directory and what attributes those objects will have. So where do businesses use Microsoft Active Directory? Well, user and group management. This is where you create those groups of administrators, the R&D department, the accounting, finance, what have you. And this is where you're going to add the permissions to those groups. Finance needs this. Accounting needs this. Admin needs a lot of this stuff. And business people may only need a subset of these systems, or sales reps, for example. And organizations typically also use it for single sign-on. Active Directory does a lot of single sign-on in the enterprise. They use it for access management. Think about all this tech that's in a business. There's going to be files, right? File servers. There's going to be printers all over the place. And who's going to manage your access to the printers? And of course, now you're an enterprise. And now you've got to be able to look through and see who did what. And you've got 100,000 users. So Active Directory helps a lot with compliance and auditing. And that's why businesses tend to use Active Directory. So if you're on AWS and you don't want to manage your own AWS, guess what? They've got a managed Active Directory system that you can use, and they call it Directory Service. And they are AWS managed high availability servers that are going to be spread across various data centers or availability zones. And if you've got a Microsoft dependent workload and it's in AWS and you don't want to have your own Active Directory services, then you can use this. But think about this. 98% of customers are in more than one cloud. You've got an AWS directory service. It's in AWS and it fails because you didn't create your own Active Directory service in two clouds. Well, then you won't be able to log into any other domains. If you're just in AWS and you don't want to manage your systems, this is beautiful. We just have to look at, what is the client's needs and what are those architectural trade-offs they have. Manage your own, use outsourced. What happens in an outage, for example? Always a trade-off. So this is where you would kind of think of it if you're not used to enterprise computing. You've got your directory service. You create your managed directories. The applications are deployed. Active Directory, knows where these systems are and it says, Mike can access it. Sally can. Billy Bob can. Louie can. So that's kind of what you're dealing with the directory service. Managed Microsoft Active Directory servers. And these are, literally speaking, hosted Windows servers on AWS. So let's talk about, three of the use cases, though typically people use AWS Managed Directory Service. So, and then we'll talk about Simple AD as well as AD Connector. So AWS Managed AD, and this way we can compare and contrast them, is actual real Microsoft Active Directory based upon AWS hosting them for you. So what's that mean? It means that you get that Microsoft Active Directory servers and everything they do, but you don't have to manage them. Now, there's another form of a directory service provided by AWS, and that's called Simple AD. And this is going to be a managed directory that's kind of compatible with Microsoft Active Directory, but not full Active Directory, less features. So maybe some small organizations could use this. Maybe it's great for a development and testing environment. So that's where you might think about using Simple AD. And it's got basic Active Directory features, users and group management, some Kerberos-based as single sign-on, but it's light in features and functionality. So we talked about the managed service, the full service, the regular Active Directory servers. We then talked about Simple AD. So let's talk about AD Connector. So if a company has an on-premise data center and they've got resources in the cloud, and once in AWS, we want to use those Microsoft Active Directory services, we can simply use something called the AD Connector. And that's really going to be a proxy service that's going to connect AWS resources to your on-premise Active Directory environment. So if an organization's got a big established data center, that would be a good place for them to have their own Active Directory servers. And that way they can still work in AWS. Of course, you could put your Active Directory servers in a few different places, and then you've got something that works pretty much in many, many cases. But it's kind of a nice, simple solution, this AD Connector. It's a great solution. It basically provides what you call pass-through authentication. Connects you as a proxy and then authenticates you. Gives you group policy management, Kerberos-based single sign-on. Very simple, and it integrates with what most enterprises already have. Okay, so now we're going to start talking about access protecting systems. So when I talked about identity and access management being the person that's knocking on your door saying, I'm here, let me in. My name's Mike. My password is this. But what if you couldn't access that door in the first place? And I talked about, if you wanted to protect a castle, maybe you'd put a 100-foot wall around the castle. Well, guess what? When it comes to security here, we're going to actually want to use things called firewalls. So we can restrict network access through firewalls. Well, and what is a firewall really going to be? I'll give you an example right now, and I'll probably get back into a little more about the AWS Identity Center and more things related to this. But I just want you guys to get the firewall and what I mean by a firewall. So in this particular environment, we're going to have the company's internal systems. This is the secure world. Everything in here has private IP addresses, and they're not reachable from the internet. So the only way you can access these systems in a traditional environment is if you're physically in the building or you've securely connected via, say, a VPN, and you're in that secure world. But if this business needs to connect to the internet for certain reasons, maybe it has to. Maybe your users want to go to the internet, for example. Maybe our users need to do some research on the internet, for example. Maybe you want your systems to be able to patch the operating systems from the internet. You need to find a way to make sure people can't get in. And that's really where that firewall is going to come in place. It's going to sit between the users and the internet. And what will happen is anything behind the firewall will be able to go through the firewall, typically to be NATed. Their private IP address will be turned into a public address. The firewall will keep track or state of the connection. Oh, that's Mike. Mike went to www.gocloudcareers.com. It allows it through the firewall out to the internet. And then when www.gocloudcareers.com, it goes from the internet to the firewall to that user Mike. And the way that occurred is the firewall kept track of that I actually requested the information to go through the firewall, and it was allowed back. That's state. By comparison, if Hal the hacker's out here and he's trying to get in, he goes through the internet, hits the firewall, and he's not allowed in. So that's the concept of a firewall. And when we talk security, it's not just identity and access management. For some reason, people are becoming obsessed with that being the form of security. It is the last line of defense. It is very important. But I wanted you to know there were other things that we're going to have to talk about later, because we're going to get pretty geeky, and we've gotten pretty geeky in some of this identity and access management center information. So let's talk about another IAM functionality. And this is going to be what's called the AWS Identity Center. Sorry, it's the AWS IAM Identity Center. And you may have remembered it being called AWS Single Sign-On if you've worked with AWS for a while. That's going to be a service that's going to enable you to centrally manage access to multiple AWS accounts with single sign-on. It'll simplify the process of managing identities because it's a managed service, makes it easier to streamline user access and single sign-on. And it's a simple place to manage authentication and authorization for your users should you not be using Active Directory. And potentially you can use it with it as well. But so the Identity Access Management Center's got some key features. Single sign-on, something that people use it for. Sign in once, get access to the other systems. That way you don't need 10 usernames and 10 passwords, both which takes time. And then how do you remember 10 different usernames and 10 different passwords? That's kind of a problem unless you use a password manager. And what happens if you use a password manager and that password manager gets hacked? Then all your passwords are gone too. So there's lots of things we need to be careful of here. The AWS Identity Center is going to provide centralized identity management because it centralizes the management of user identities and permissions. And that will integrate into AWS Identity and Access Management to give you a good granular control over who's allowed to what. Now, AWS has this concept of organizations where you can basically have multiple different accounts and use identity and access permissions to get information inside of those accounts. And one of the plans is if something bad happens here, hopefully it doesn't go to another organization that's part of your systems. Limit the blast radius, if you will. So it'll integrate into that because it's an AWS product inside of another AWS construct. And of course, the AWS Identity Center is going to support SAML because everything's either going to be SAML 2.0 or OpenID in today's world. And that will support obviously federated identities from external identity providers as well, like Active Directory. So some things to think about is it can help manage access to applications. Manage applications to say, Office 365 or Salesforce. And it's giving you all those SSO capabilities for both AWS and non-AWS stuff. It can also help with user lifecycle management. So it's hard to manage, all these identities. And this can help automate user provisioning and also deprovisioning or removers from the systems of the corporate directory when necessary. And anytime you're dealing with that, you have to constantly think about, you can't just give access to users and not remove it when they don't need it. Let's say you've got a systems administrator that needs access to a lot of the systems. Now that person's a manager. They don't need access to those same systems anymore. So you remove access to those systems. Now that manager probably needs access to a payroll system or a paid vacation and approval tracking system. So constantly migrating these permissions based upon people's needs and never giving people more than they need to do their job, following that principle of least privilege. Another good thing about the AWS Identity Center is it supports multi-factor authentication. So various forms, of methods, tokens, that kind of thing, one-time passwords. So how would you set this up? You go to the AWS Identity Center, that IAM Identity Center. You can access that directly from the management console. You go to Identity Center, you enable the service and configure basic settings. It's pretty simple to set up. You then integrate it with any identity providers you want, like Microsoft Active Directory. You configure SAML 2.0 or the OIDC federation is needed. As we talked about the other approach, you assign user access, you create your users and your user groups. You assign the users to the groups. You configure your user portals. So you'll set up the user portal so you've got centralized access point for your users. You'll customize to fit the organization's branding needs. So it looks the way you want it to feel. You enable multi-factor authentication, hopefully, for better security than you would. Or at least require multi-factor authentication for sensitive resources or sensitive applications, or maybe privileged accounts. You'll monitor and you'll audit access. That's pretty much the way that we're going to get this stuff set up. All right, now we're going to start talking about security, which is one of my favorite topics. And I've trained so many security architects that are working at so many great companies. I love discussing security. Tyrone, how long has it been since the last time I asked questions? Do we need to take a break or are we good? Okay, my team says we've got a few more minutes before we start taking questions, so I'll take it from there. So when we talk about security, there's some oddities of cloud security or anytime you deal with other third-party providers. So we're going to talk about that shared security model. We'll talk about the principle of least privilege. We'll talk about identity and access management. We're going to talk about account strategies. We'll talk about access control lists, security groups, AWS, their firewall like WAF. We'll talk about intrusion detection and intrusion prevention systems. We'll talk about the next generation firewalls that provide optimal security. We'll talk about distributed service, denial of service attacks. We'll talk about the service catalog. We'll get into the systems manager parameter store and so much. First thing that you've got to understand with cloud security is it's a responsibility that's shared between the cloud provider and the user. And in order to think about this, AWS maintains the security of their cloud. Azure maintains the security of their cloud. Google maintains the security of their cloud. And if they get hacked, you get hacked. So when Azure had people access, Azure Cosmos, the NoSQL database, the Azure version of AWS DynamoDB. They managed that. So when Azure got hacked, the users' accounts that were using Cosmos, their managed NoSQL server, a lot of their information was stolen. So now you've got to think about in the cloud, are the cloud providers doing their job? And on their side, and what you need to do on your side. So remember, you've got a lot less control here than you would in, say, the data center. Doesn't mean it's not secure, but now you need to plan for multiple sets of problems that are new problems that you didn't have before. So AWS manages their stuff. You manage yours. AWS manages the network, the routers, the switches, the firewalls. You manage yours. They manage the servers and the hypervisors. You manage your virtual machine. You see where I'm headed from? So think about that. That you've got this shared security model. And all in all, the customer is responsible for their identity and access management, users and roles, patching of their own virtual machines or non-managed virtual machines, their own firewall configuration, their own access list configuration, their own security group communication, physical security to the devices that connect you to the cloud, what your demilitarized zones are going to look like, what your encryption kinds that you're going to use, so you're going to be responsible for pretty much everything except the underlying infrastructure. And you hope the provider does their job managing underlying infrastructure. And if they don't manage their underlying infrastructure, or they test something and it goes wrong, it can take lots of their customers down. Maybe visually, this will help. So the servers, physical, AWS manages them. Their managed databases, they manage them, like DynamoDB. Their storage, they manage those RAID arrays. They manage those. So if a hard drive fails, they go and replace it. They manage the networking, routers and switches, the cabling. They manage their availability zones or data center. They manage their regions. They manage their edge locations. But you are responsible for all your network security that you can do on top of what they've done, all of your data, any encryption or decryption you have between yourself and the cloud, any encryption you have between systems and systems that you have in the cloud, any a service that rolls between one system and another, you are in charge of that. You are in charge of your application. So if somebody makes a bad application, it'll get hacked. If you allow your users to come up with Cindy the cat as a username and Cindy the cat as a password, let's face it, you'll have a problem. If you're not careful with your networking and you let your traffic go to the wrong places and you expose routes that you shouldn't expose, you'll be attacked and it will be your fault. If you have a user and 16% of all hacking attempts are related to misconfigured S3 buckets, not because someone doesn't know how to click a few boxes and configure the bucket, it's because they don't understand which one to use and they set the wrong permissions and then they make company files accessed. So a lot of hacking events are related to misconfigured object storage buckets or S3 buckets. So there's that. And then you need to think about all the traffic, your entry and exit points of your systems. So the first thing to talk about when it comes to security is not giving people access to more than they need. It's that principle of least privilege. If someone doesn't need to plug into your network, don't let them plug into your network. If someone doesn't need the ability to create or delete an account, don't give them that right. This is very, very similar, not completely the same, but very similar to what the military would call need to know. If you don't need to know it, you don't. It's slightly different, and there's some subtleties that if I were to teach a CISSP program, I would talk about it, but functionally, they're pretty similar. So give people the least amount of privileges they need, and when they don't need them anymore, take them back. So I always go back to this. We've got two people. Where it says on the top, that could be a general. And the general needs to access the system, and he's given permission. On the user on the below, that could be what's called like an E1 or an E2, someone that just enlisted that's new to the service. They try to access it. They don't have that kind of clearance, so they're not given it, but the general would be. Could be the systems administrator in the client that needs access to one of the Linux servers. And the regular user tries to log into that Linux server and they're not allowed. So always think about that. Now, AWS has a concept of a network firewall. And it is a high availability router system. And it is a virtual system. And like any other firewall, it's designed to keep unwanted traffic out of the system. Now, one good thing to think about is when you're dealing with these virtual appliances, they're very highly available. So they are a system that could be on any server anywhere where you can think about it. So you can use the AWS Network Firewall for, say, perimeter security, and you can set it up because an easy policy, and it's not going to go down like a traditional firewall in a data center. It could have a hardware problem go down, and then the other firewall will take up. This is a logical firewall, which could be across multiple data centers at the same time. So if any of you are familiar with networking and you understand why we put a loopback address on a router, because that's a port that's logical and will never go down, it's really the same thing here. So I hope that can help. Now, a firewall basically blocks all incoming traffic by default, and it allows your outgoing traffic to go in. But what you do in firewalls is you create custom rules. Either allow certain traffic, maybe allow port 443 to a web server in a demilitarized zone, and the firewall only allows TCP port 443 in, and that's it. And it only allows TCP 443 to this one subnet that's got the load balancer of many web servers. So one of the things to think about is because it's a firewall, you get a lot of information. So you'll get a lot of logging and monitoring, which is great, especially if you tie it into a SIEM system to correlate events and that kind of thing. Now, AWS also has another firewall for web applications called the Web Application Firewall. And that's a security system for controlling access to the AWS public cloud. And WAF is a basic firewall. It's not to the degree of a next generation firewall that you'd get from, say, Cisco or Palo Alto or Fortinet, and I can tell you the differences between them. But it is a simple firewall that you can use. And basically, it's something that you just stick on, say, your load balancer, or your content or your load balancer, or something that uses a virtual firewall. You stick it on an API gateway, that kind of thing. Basic, lightweight firewall that's completely managed by AWS. And it's a layer 7 firewall. So it's going to be able to look at the application layer, meaning it can look at the header, so the country the request originate from. It'll be able to look for strings that appear in the results or text. It'll be able to look at the length of the request. It'll be able to look for if there's some SQL code there that would potentially be malicious for like an SQL injection attack. And it's going to provide the presence of a script. And it'll look for the presence of a script if you're looking for like a cross-site scripting thing. So it's a basic application layer firewall. You're going to use it maybe on a CloudFront distribution. You put it on an API gateway or a REST API or an application load balancer. And the nice thing with WAF is it's going to integrate very simply into Amazon Cognito user pools. It will block the request at the edge location before they even get on your network. And it's going to provide basic firewall-like functionalities. And I'll tell you the difference why I say basic in a minute. So if a system's going on, you'll create a web access control list that is just like an ACL on a router, but firewalls are stateful, so you'll apply them only in one direction. And the rules will be either allow this or not allow that. Kind of like exactly when I taught you how to do an access control list. So the way you'll set this up is you'll enable WAF on the appliance or the device. You'll create a policy filter with access to the device. And then WAF is going to look at it and say that the traffic conform to policy. And if so, allow it. And if not, it's allowed out. And because it's AWS, it'll integrate very nicely with with all your CloudWatch, CloudTrail, and all those things. So let's look at what this actually is real quick. It's a basic firewall, and I'll tell you why I say basic in a minute. You put it on an AWS service, and it protects that AWS service. Here's why I say AWS is a basic service. Let's talk about what AWS WAF can do, and let's talk about what a next-generation firewall, like those made by Cisco, Checkpoint, Palo Alto, Fortinet, and other companies do. WAF is a firewall, and like all good firewalls, it allows your traffic out and you return traffic in, and it doesn't allow anything in except what you permit. WAF does a beautiful job with that. WAF even has the ability to integrate into a third-party system that will get, that'll also be able to say, hey, here's a new attack that's occurred. Firewall, be smart enough to recognize this new attack. So it doesn't come default, but you can integrate WAF into something else to get some basic intrusion detection, intrusion prevention. Here is what an enterprise-grade next-generation firewall does. Does everything we talked about. Here is, and I'll give you an example so you can think about it from a heuristics perspective. It allows your traffic out to the internet, your return traffic in, blocks all traffic, just like AWS WAF. Can look at it, the application from layer 7, just like AWS WAF. But here's what a next-generation firewall will do. The next-generation firewall not only has been given the signatures of previous attacks like you can subscribe to with AWS, but it's smart. It's constantly watching the system. So it's looking at the network. It's looking at patterns of traffic, and it says, I don't like this. Let's stop it even before we know it. And what's the system like? What is heuristics like? Have any of you ever used a credit card? Now, if you're not used to being in 3 countries a week like me, if you go, let's say you're in Tokyo, Japan. If you fly from Tokyo, Japan to Singapore, and you go from Singapore to Sydney, and you go from Sydney to UAE, and the next week you try to go to the UK, I promise you, your credit card company will call you and shut off your credit card until you tell them that I'm on a trip, and then they'll allow it to go through. And why is that? Because the credit card companies have good security, and they're trying to say this is a pattern of behavior that doesn't feel right. So block it. Now, me, when I traveled, I was an architect working for Cisco, and I was in 3 countries a week. Initially, they blocked my card, and I told them this is my pattern of behavior. And then, when I'd leave New York, and I'd go to San Jose, and the next day I was in London, and 2 days later I was in Dubai, and then I was in Sydney, and then after that I was in Hong Kong. It was like, all right, that's Mike Gibbs traveling. The system knew it. So the enterprise next generation firewalls can sense the attacks, and they can actually stop a majority of the attacks by recognizing patterns of behavior that just shouldn't occur, in addition to doing all these same great things. So when it comes to an architecture perspective, do you need a robust next generation firewall? Or can you get away with something by the cloud provider? If you've got multi-clouds, you're going to need similar things that you can use in all 3 clouds. If you've got a single cloud, it's simplicity and elegance, which you're getting, because this is simple and elegant for most stuff. But is it big enough for a big enterprise? Just kind of think about that, and I hope that kind of makes sense. So this is typically where you would use these. And honestly, look at how elegant it really is. You go straight to your load balancer. You pop in the AWS Shield, which is their DDoS protection that comes with the CloudFront. You put on your WAF directly on that load balancer. That's your firewall. Your firewall's got WAF. It's securing the load balancer. Then you put a security group on the load balancer. And you've got basic security for your web application. And then you can still put an access control list protecting the subnet after that, and put a security group on your web servers, and you can lock those servers down, just harden those servers, add some anti-malware protection, disable services. So you've got a very simple and elegant security solution here that is very, very easy to understand with AWS WAF. Okay, so Tyra, let's take a break and see if anyone has questions, because I'm going to get into distributed denial of service attacks next, and I want to make sure everybody is fresh. If you're having a good time, please hit the like button, subscribe to the channel, and hit the bell to be notified of new videos. If you're just joining us, there's about 40 plus labs that I'd love you to do, and you can sign up for them. They're completely free. My team will pop the link to that in the chat box. It's also in the description of this video. And in the description of this video, we've got so many free ebooks and resources to help you in your career, We've got a free AWS networking course that was taught by three CCIEs, as well as a CCNP network architect, and he's a rock star. We put that out there, the free certification. It's all free. So try to look in the description of these videos. You're going to see a lot of good stuff. And it's all free. Tyrone, any questions? If associate certs need such long boot camps, you wonder what the professional will look like. So let me be fair. This is not what we're doing, just an associate bootcamp. I could get somebody through an AWS Solution Architect Associate exam in about 6 hours of training. It's no big deal. What we provided in this bootcamp was the AWS Solutions Architect Associate, 50 or 60% of the Solutions Architect Professional, about 40% of the AWS Advanced Networking, and about 40% of the AWS Advanced Security, all in the same course. And I did that because the Solution Architect Associate alone is not going to be enough for anyone. And I wanted people to have a much better opportunity. I wanted people to get a much better education. In my view, it's better to give you the preparation and give you the knowledge and teach you how stuff works than it is to say, I could help you pass that exam. And it's because passing an exam is not the challenge. That's the easy part. Don't get me wrong. You got to learn how the provider asks their questions, maybe get a good practice test to make sure that when they ask a question a certain way, you know how to answer it a certain way. If you're taking a certification, you've been in the field for a long time, you have to forget two-thirds of what you know to take a certification, because certifications are more at that beginner level, regardless of the certification. So you have to almost try to think like, how would a newbie do it versus how would you do it in the real world? But no, I added a lot more to this. But, let's answer the question in reality. So a CCIE certification is about 2,000 to 5,000 hours of presentation of training time. And AWS Solutions Architect Professional certification, that could be done in about 20 hours of training time if you're just focused on just that. And what is the certification? The name of a service and how to configure that service. I'm more interested in you not only knowing how to pass an exam, but actually having some knowledge in your head. So you know how to think about these things holistically, and you know how to be able to communicate it to someone else. And if you're on an interview and someone asks you a question and they say, where would this technology fit in? And all I teach you is the name of it and how to configure it. You won't know how to answer that. So I'm trying to give you as much as I can for free. Can AWS WAF work in a hybrid environment? Well, yes, it could, but let's talk about how you would really do things more pragmatically. If you've got one provider's WAF on one side and one provider's WAF on the other side, and you've got two web servers sitting, and you have half your web servers in your data center and half of your web servers in the cloud, you're really going to want to make sure that you have the same level of security policies for both web servers. So in that case, you're not going to put AWS WAF inside of your data center, but you could go with a more robust enterprise-grade firewall like a Cisco or a Palo Alto or a Fortinet or a Checkpoint, and you probably would. Now, is there any laws that says you can't use this AWS proprietary thing in AWS and this Azure proprietary thing in Azure? Well, when it breaks, who do you call? Where was the source of the problem really coming from? So how are you going to compare your logs with two different systems compared to using the same logs from similar systems? So you can do it. The answer is yes. The question is, if you're going to go single cloud, why are you going to go in there? For the most part, you're going to go with the synergies and that simplicity and the elegance of one provider stuff all working natively with its own stuff. If you're going to go to the point where you're going to use a hybrid cloud or a multi-cloud, or in most cases, a hybrid multi-cloud, you're going there because you want more performance, more availability, and the ability to take the best each provider has to offer. And by doing that, you're going to lock yourself into a hole by using proprietary things. So by the time you're going to a hybrid cloud, it probably doesn't make sense to use WAF. Could, yes, but should you is the question. But it also depends on what that organization is doing. Are they going to move it all to AWS? Do they need the latest and greatest security? What are they protecting behind that? What are the value of the assets they have? And maybe the WAF is good enough. But for a bank, you might put 2 layers of next generation firewalls from 2 different vendors. Why? Vendor 1's firewall may have this weakness and vendor 2 firewall doesn't. Kind of like martial arts. You may learn jujitsu to learn how to fight on the ground. You might study Kali or Salat to learn how to fight with sticks or edged weapons. You might use karate to learn how to strike, or kickboxing or Muay Thai. So it's that kind of thing. Each one of these things has their strengths and weaknesses. So I hope I gave you a good answer there, or I hope I answered your question. Won't the next generation firewall take the good out traffic accidentally and detect in its attempt to direct the wrong traffic? Well, it could. Now, the key is, would you rather be more sensitive or less sensitive? Kind of like on a medical test. Is it better to be more sensitive or more specific? So, and I think Leonard's a medical professional. So typically when you're doing a screener, you want some big sensitive tests to catch anybody that might have it. And then you want to nail it down with some level of specificity thereafter. And when it comes to higher security, you might want to be a little extra zealous on security and block something, even if it's not, and potentially lose out on a little bit of business to protect yourself. Or you could go with a more open, and well, we're more open, but we're more susceptible to being hacked. So the way you're going to deal with this is you will fine tune the rules, you'll constantly update the policies, and you'll look at patterns of behavior and anomalies, and you'll adjust it. And this process is really the same way a credit card company would manage you. They've got a process to look for. Okay, well, maybe this pattern of behavior is normal. Maybe this pattern is not. Maybe we classify it as this, and therefore we allow it to go through in the end because we now know that it's not a problem. But sometimes it's better to be safer than sorry. And that's how you set these systems up. But it's a great question. Okay. So let's get back into security. I love security. Give me a hashtag AWS security so they know that you're here. So the next thing we're going to talk about is a distributed denial of service attack. And I want you to see what this is here. So in this particular environment, what you see is an attacker, or that's the hacker. And the attacker is going to get control of a server. And that's going to infect a whole lot of systems and then launch an attack. So it's kind of like bringing a big army to overwhelm one soldier. And in this case, it's bringing a big army to overwhelm one server. So that's really what a distributed denial of service attack is. So if you can handle 100,000 requests per minute, and I send 1 million requests at you, you won't be able to handle it. And let's be fair, there were websites that would accidentally DDoS themselves. They'd say, I have this one thing, and they would email, say, 100,000 subscribers, and it'll be for sale at exactly 9 a.m. and 0 seconds. And at 9 a.m. and 0 seconds, 10,000 people try to buy the same thing, and they take the website down. Well, that was because the company didn't know their own business, and they didn't know their client base well. But in this case, it's when an attacker wants to use some other systems to attack and overwhelm a single system. And that is a denial of service attack. Can autoscaling help here? Yeah, it sure can. If you can handle 100,000 requests naturally, and you get hit with 500,000 requests, you can autoscale out and add additional servers. Now, that'll be a real costly way to be dealing with the attack, but at least it'll keep you up in business. So that's really what's going on. So how do we prevent these things? Well, you've got a good security posture. Next generation firewalls, access control lists, protecting subnets, end system and endpoint protection, IDS, IPS systems, multiple layers of firewalls, lots of stuff that we can do. But we can protect a subnet with an access control list to reduce the unwanted traffic going on. We can put a security group on that server, which doesn't allow bad traffic into the server. We can auto scale. And we can use really good, strong firewalls, IDS, IPS systems, and many other things. And, if we're going to go on this simple side, we go with an AWS WAF because it knows how to recognize common attacks. And we add something called AWS Shield. And here's what these systems, these DDoS prevention systems that you typically see in a content delivery network, which would be a great place to put Shield. You could also put in a load balancer or a virtual machine or Route 53 or some other things. But you can put it in a lot of places, but it's the recognized patterns of behavior that are not normal and not forwarding them. So when it comes to content delivery networks, they not only cache our information, but they can actually look at the traffic and say, this doesn't feel right. This overly large ICMP ping message coming in doesn't feel right. Maybe I'll block it. I just had 8,000 TCP send connections coming in. That doesn't feel right. Maybe block those half-open connections so you don't get a DDoS attack. And any of these systems do it, whether it be Cloudflares that would do it, or it would be Azure systems that would do it, or Google systems that would do it. AWS has their DDoS system on their cloud, on their, what they call it, content delivery network, and they call it Shield. And it's a great system, like all of these other DDoS systems that are deployed on content delivery networks. Now, AWS has two versions of Shield. Shield Standard, and that's given to you free if you use a web application firewall. And then there's Shield Advanced, which provides more protection to virtual machines, load balancers, and gives you more options. So Shield Standard is free. Now, unfortunately, sometimes you get what you pay for. And it'll protect against the most common DDoS attacks, things like SYNAC attacks, reflection attacks, HTTP slow reads. And what it has is it's got a standards-based policy. And you set up a policy, but it is static. So good if the system already knows about it and if there's been a policy. By comparison, Shield Advanced is a lot better. Shield Advanced comes with more DDoS protection. It's also, you have to pay for it. It gives you much better intelligent attack detection and gives you some ability to mitigate some attacks as they're occurring. It's going to be dynamic, and it's going to look for patterns of behavior that are abnormal, and it can deploy, say, an ACL on demand to block a bad user or something like this. It even gives you a 24/7 DDoS response team for businesses or people on businesses on enterprise support. So this is going to be something that matters for organizations that need real security and real DDoS protection. They're going to go to Shield Advanced, and it's a great service. So let's talk about the service catalog. So if an organization knows what they're putting on their systems, they can be much more secure. When I first started my career in tech, I think for the first 2 months, they were calling me Sniffer Boy. A sniffer was a protocol analyzer, and they literally had me plugging in all over the network to see what I could actually find. Hence the name I earned, Sniffer Boy. I don't want to go back to that. I don't like, plugging into the network and all that other stuff. It was fun, but it wasn't. So after inspecting lots of people's traffic, you would be amazed at what you'd find. People would put these little back doors into your system. This person wanted to run an operating system that wouldn't be patched in the last 2.5 years because that was the flavor they liked. People would set up file and video sharing services on the system. You couldn't imagine what companies were paying for bandwidth and the security holes the employees were created. So organizations do inspect traffic and monitor traffic. But the service catalog enables you to create a catalog of services that are approved. So you don't get that. And that way, when your employees want to add something, they go to the catalog and they deploy what they're allowed to versus anything they feel like. A great way to enhance the security of your systems. Service catalog can manage resources in the marketplace, the AWS marketplace. And what's the AWS marketplace? If you need a reverse proxy and enterprise features and functionality, you get one from F5. You need a commercial enterprise grade firewall to run on AWS. You get it from Cisco or Palo Alto or Fortinet or Checkpoint from the AWS marketplace. You need certain business applications pre-deployed on virtual machines. It's great. You go to the AWS marketplace, the Azure marketplace, the Google marketplace. They all have them. But so AWS Service Catalog can do that. But you can create what you want as your virtual machine images to have a golden build, or virtual servers, or software, or databases, to anything you want. That's allowed. You store it by using the Service Catalog. And that way, you can centrally manage your applications that users are allowed to deploy. I mean, it's a really great feature and functionality to use these things. So the way you set it up is users can access this CloudFormation script or this kind of thing to go kick off these features and functions. They go to the Service Catalog, they're allowed. Then you'd pull the infrastructure as code script, like the AWS CloudFormation script, and use that to deploy your resources exactly according to the company's standards. So these types of things, any way you can standardize an image or standardize anything, really give you the ability to add a lot of robust security to your system. So this is great. So let's talk about some key features of the Service Catalog. It gives you the ability to create products. And that's where you create and manage whatever that product is. It could be an EC2 instance or a virtual machine, or a database, a custom application. And they also have the concept of portfolios. So what happens is you can have these products for these things. These are the financial applications, you call them products. And you'd create a portfolio, and you'd put these applications, these individual products inside of that portfolio. Same way it is when you go shopping. Oh, let me go look at the outdoor gear. And inside there, you see packs and that kind of thing. So basically, same thing we're talking about. But in this case, the products are maybe a virtual machine or an application that's going to be launched on a virtual machine or a container, that kind of thing. Now, the other thing this is going to provide for is something called version control. You may have 50 different versions of the application, or 1,000 different versions. And you may have found out that version 996 is something you don't want to use. But it'll enable you typically to go back to good versions or avoid old versions and make sure you don't have that old version again in the future. So, version control. It also helps with governance and access control. You can find who can access what product portfolios. So, only the right people are deploying what they should be allowed to do. It gives you the ability to apply what's called a constraint. And you can apply a constraint to enforce, various organization policies, like resource limits or tags or specific configurations. So it gets you real granular at making sure that people put what you want. And obviously you can use like a CloudFormation template or an infrastructure as code template. What's great with these things, especially when you go AWS to AWS or Azure to Azure, because they make these systems, it's very easy to integrate with them. So it's going to be you'll integrate it with CloudFormation or an AWS organization or an AWS IAM any way you want, because it's already there. So where would you use something like the Service Catalog? Service management, IT service management. It gives you the ability to centrally manage the IT services. It provides a self-service portal. So end users will be able to say, these are what I can deploy. And it's quick and easy, and you don't need a million sets of approval, because if you've got access to it, you've got access to it. And if you don't, you don't. From a governance compliance perspective, enforcing these policies and compliance is, all about controlling which services are deployed by whom and who can manage them. This really helps with that. And it can make sure that consistent configurations and security practices are applied well across the organization. It can help with resource optimization as well, because if you've got a standardized pre-approved configuration, you can set that to be as efficient as you need it to be. And that'll keep people from over-provisioning and provisioning anything, to make sure they've got good use to resources. So how do you set this up? You basically create your product and portfolios. That's going to be in the Service Catalog console. You set up your access controls, basically your IAM roles and policies to determine who can access what products from the store. You define your user groups and assign permissions to them to make sure that only authorized users can access authorized stuff. You define whatever constraints that you actually need to be, like only these types of virtual machines or regions or tags, and then provision the products. Users access the products from the management console, the CLI, the API, whatever they feel like, and they can, monitor and manage these products. Some best practices with the AWS Service Catalog. Make sure you organize products or portfolios by either organizational unit or project so it's easy to find. Structure the portfolios in a way that reflects the organization structure, maybe by department or project or environment. Use templates for consistency. Look, if you can manage to have one infrastructure as code template that everybody can do, it's going to be a lot easier than if Billy and Hal and Sally and Joey and Maria and Maddie all go in there and do it their own ways. So, think of it that way. Make sure you've got good access control and policies, because if you're giving people can now access this system to do something, and now they're able to deploy units, and they're not the right people, you're going to run into trouble. So make sure you use good identity and access management and monitor it. In fact, that's the secret to everything. Deploy it, look and see what's going, and tune accordingly. That's why companies are constantly updating architectures, because they may have thought this would work, but it didn't. It didn't provide value for the business. Let's not move forward. Let's scrap this architecture and move to something else. We thought we were going to get savings going to the cloud, but it costs 2.5 times more. All right, let's pull this stuff out of the cloud and go back and stick this stuff in the cloud where it's cheaper. So it's all about a tuning process over time. So monitor and optimize. And, you're not going to want the same configurations potentially 5 years from now. So constantly update them, maintain those products in that catalog. All right, so now another one. The Systems Manager parameter store. So I want you to think about it. When it comes to security, you've got your passwords, maybe these database strings, you got software licenses. That's a lot of secret stuff to keep track of. You don't want to leave that stuff on your desk because, it'll be seen. And at the same time, you put it in a safe underneath your desk, and then something happens and you can't go to work, or worse happens. How does somebody access that, that safe? What do they do? Call in a locksmith, pack into the safe, break it. So the Systems Manager parameter store is an online way with AWS to store your secret stuff, like passwords, database strings, license codes, API keys. And if you're going to store your stuff, if it matters, encrypted. So the Systems Manager parameter store enables you to encrypt your stuff. I personally think they should call it the Secret Stuff Store, but I don't work in marketing. So think about it this way. You're able to secure your information in a secure environment. It's encrypted, and it enables you to separate your code from your passwords, because you want that to be in 2 different places. It provides an excellent means to audit access to see who did what. It provides a method to track various password use to make sure that you don't have one employee that's logging in 24 hours a day from different locations because maybe they shared their password. So I think we covered the Systems Manager parameter store. Now, there is another Secrets Manager. So we also have the AWS Secrets Manager. And that is going to be another managed service that's going to be designed to securely store and manage and retrieve sensitive information. Again, database credentials, APIs, keys, and other secrets. Because it's managed, it'll make it relatively easy to maintain and rotate secrets, ensuring they're going to be kept secure and accessible to make sure that only the authorized users and applications. So when we think about the Secrets Manager, think about secure storage. Secrets are encrypted at rest using the AWS Key Management Service. Think about secret rotation. So those secrets are going to be constantly rotated. And you can do that with, say, Lambda, or integrate it with Lambda to define a logic to rotate your secrets. It provides very good IAM fine grace control. So this user can access what and whom and in which applications. And it provides a great way to audit and monitoring your systems. Integrates with CloudTrail. So remember, CloudWatch as logging and CloudTrail as auditing. And that'll help you monitor the use of your secrets and detect any kind of unauthorized access. Because it's AWS, it's integrated with so many other things, like the databases or the Amazon relational database systems, Redshift, virtual machines like EC2. So very simple because it's AWS integrating with AWS. Also works with Lambda functions, ECS, the Elastic containers, and other types of services. Secrets Manager works for that programmatic access, so for one system to access another system. So where do you typically use these things? So if you've got database credentials, here's a great place where you can put them. You can store and manage your database credentials for any of the Amazon relational database systems, Redshift, or other databases, and you can rotate those credentials fairly frequently to enhance your security. You might want to use it for API key management. You're going to have to store API keys for third-party services and even internal APIs. And you're going to want to control access to these API keys and rotate them periodically to prevent misuse. And this can help with that. You're going to want to use it for application secrets. So think about application-specific secrets like OAuth tokens or SSH keys and encryption keys. And this can ensure that the applications can securely retrieve and use these secrets at a runtime. Also helpful for disaster recovery because it gives you the ability to back up your secrets somewhere and ensure that your sensitive information is only going to be available when it's needed. How do you set this up? Basically, you go to the control management console or the CLI. You create a secret. You define the secret's key value pairs and specify any necessary what the encryption settings will be. You'll define the rotation settings. You'll configure automatic rotation, ideally for the secret, or you can choose a predefined rotation, or even create a custom Lambda function to rotate your keys and the logic behind that. You can set up your access policies. So those IAM policies to control who has access and who can manage the secret. And you will apply these to whatever the appropriate users are, or groups are, or roles are inside of your AWS account. When needed, users can use the AWS Secrets Manager, either the API or the software development kit, to retrieve the secrets programmatically. And you can integrate secret retrieval into your applications to fetch and use these secrets securely. And of course, you monitor it and you audit. Make sure the systems are doing what they're supposed to be, review logs, detect if any unauthorized use is occurring. So we talked about the systems manager parameter store for this, and we talked about the secrets manager. So let's kind of compare and contrast these. The parameter store can store unencrypted passwords and encrypted passwords, where the secrets manager is only encrypted data. If we want credential and secrets rotation, which we probably do, that's going to be more of the secrets manager. So I hope that kind of helped clear some of that stuff up. So let's talk about the AWS Security Hub. When it comes to security, there's a lot of systems that need to be managed. And it typically needs some really good security management software. AWS has a security hub for managing the systems on AWS. If you're in multiple clouds, like 98% of organizations, you may want to use some other software that integrates into these things or is a bigger, more global system. But the AWS Security Hub is an excellent environment in AWS to give you security information in your AWS account. And what it does is it'll help monitor and manage the security of your accounts because it'll aggregate, organize, and prioritize security findings from multiple AWS services or third-party tools that are going to find things. These tools can be checked against, say, databases of, say, best practice standards to help you identify oversights or trends, and it'll give you that you might need to fix or give you some insights from what it finds. It gives you a centralized view to look at things, and it'll pull information from like Amazon Guard Duty, AWS Config, the AWS Firewall Manager, and other stuff. And thankfully, it integrates with other third-party tools to give you a good view of your systems in AWS. It can help with automated compliance checks, and it'll constantly monitor your environment for compliance with with industry standards and best practices, or at least what it considers to be them. And it will support frameworks like the CIS AWS Foundations benchmark. It'll support like a PCI DSS framework or an AWS Foundational Security Best Practices framework. Organizations may be using a different framework, but that's something to at least think about. It'll provide some custom insights and alerts, and it enable you to create custom insights and filters to basically prioritize findings based upon the organization's security needs. And it'll integrate with CloudWatch and SNS to send alerts and notifications when necessary. It integrates with AWS organizations. We haven't talked about them yet, but that's where you've got a company that basically has multiple accounts and they get one single company billing, better prices because they aggregate it all together, but they keep these accounts separate and use identity and access management to talk to each other across accounts to limit the blast radius if something goes wrong. It gives you some security findings in an aggregated result and gives you response and remediation. So it's set up pretty easily. You go to the AWS Security Hub in the, say, the AWS Management Console, and you navigate to Security Hub and you enable it. You choose the security standards that you need for compliance checks. You integrate this system with various AWS services like Guard Duty or Firewall Manager or Config, and you configure these services to basically send your findings to the Security Hub. You set up whatever you feel are going to be custom insights, and maybe you'll set up some filters to prioritize certain things over other things, and you can predefine these. And then you configure your notifications. Does it go into CloudWatch? Do you want to send off an Amazon Simple Notification Service, text to you, or something like that? You create notification rules. And then you'll automate whatever kind of response you want to do, maybe an AWS Lambda function. So that's pretty it. And then you're going to monitor and review and just change things. So remember, any of these systems, any of these security hubs, and I'm saying this because I saw someone got a LinkedIn about a week ago and say, you don't need to have penetration testing. You don't need security audits. You just need to go to the security hub. That is nothing further from the truth. Tools are great. Consoles are great, but they miss stuff. So they miss things. That's why you can't just run a code check and deploy code and not expect it to crash. You have to deploy a code check, and organizations have to test it and stress test it. And then at one point, it's like, okay, now let's give this to a percentage of users. And then if it works, we'll give it to everybody. So understand this is just one of those things. It's the equivalent of a code check by looking at your system and saying, looks right. But that doesn't mean it's going to be right. But this is as good as any other system. All these systems have that problem. So let's talk about the AWS Resource Access Manager. And the AWS Resource Access Manager is going to be a service that's going to enable you to share your AWS resources with any account or with either within your AWS organization or any AWS account. So if you've got something and you want to share it with others, this is the Resource Access Manager. And you might do this to facilitate collaboration and resource sharing with other organizations and still keep security and control of your own AWS environment. So maybe you want to share something like a subnet with another organization. Maybe you have servers on one subnet need to talk with servers on another subnet in another organization. Maybe you want to share your transit gateway for routing through your system. Maybe you want to share some license manager configurations, something like that. Maybe you want to share resources with specific AWS accounts or all AWS accounts inside of an organization. And this is where the AWS Resource Access Management is going to come into play. It's going to be very good at giving you fine-grained access control on the basis of identity and access management. So remember, it's identity and access management-based security. Identity and access management is the person knocking on your door saying, I am here. And you're saying, well, welcome, or no, you're not allowed in, or you're allowed in and only access to this. There are other ways using network security to firewall off this and create a greater degree of security between accounts. But if you're going to do it just based on IAM, and in many cases it's appropriate to do so, you're basically using IAM to separate you and another organization, as opposed to taking two different VPCs and then labeling certain routing in between those VPCs. This is an IAM way to do it. And it's a totally appropriate way, but there's lots of ways you can segregate or segment your systems or micro-segment your systems, either in the cloud or the data center. Very useful for cross-account sharing. Remember, cross-account sharing is when you share information with another account. You're a PC manufacturer and you need to share information with a hard drive manufacturer, or a DRAM manufacturer, or a CPU manufacturer, or a GPU manufacturer, what have you. So very simple, easy to set up, centralized resource management. And it ensures that whatever your shared resources are going to adhere to those identity and access management policies. And it'll give you the ability basically to log and see whatever happened through CrowdStrike. So very convenient service. So how do you set this up? You basically enable the AWS Resource Access Manager, say in the management console. You ensure that your accounts are part of an AWS organization if you want to share resources with that organization. You're going to create a resource share. And in the resource share, it's not that different than sharing resources on any other server. You're going to define the resources you want to share, and you'll specify either the AWS accounts you want to share them with or organizational units you want to share them with. You'll set your permissions just like you would on any kind of server sharing environment, and that's going to be your IAM permissions. You'll accept the resource shares. The receiving accounts must also, you'll send them an invitation. They'll send you one. They need to accept it, that kind of thing. And then after they're accepted, whatever resources you allow to be shared are going to be, they'll be able to manage. And then, of course, you monitor and manage. Use CloudTrail, which has auditing to log it and see what happened. And that's how you'll deal with these things. You don't need a share. You'll revoke it here. When a new share, you'll create it here. So let's talk about the AWS Firewall Manager. Firewalls are very essential for security because, as I mentioned before, identity and access management is someone knocking your door saying, I'm here. But if you really had a high security house and you could put a giant wall over your house with a moat that would be impossible to swim across or near impossible to swim across, you can add some defense and depth to your security. And it's much more robust than just saying, I'm here. So you'll be using firewalls everywhere. Now, managing thousands of firewalls or hundreds of firewalls can get pretty cumbersome. So AWS has something called the Firewall Manager. And that's going to be a security management service to make it easier to essentially manage and configure firewall rules across your accounts, making sure they're consistent. And so in a single place, you'll go to see what's going on with your security policies. It supports, your key things. So if you're using the AWS Network Firewall, or you're using AWS WAF, or AWS Shield, or VPC security groups, this is going to be very helpful to you. It will be less helpful if you're using other non-AWS tools. That's why you got to look at it and see where it's going to help. Might still be helpful in either way. It'll manage your security groups. So if you've got security groups coming into every service, and you should, and you also have a couple of other AWS things, this could be very helpful to help you think about it. If you're using AWS organizations and you've got a firewall between you and somebody else, well, if you're using different VCCs and you've got firewalls, that'll help. But if you're using AWS organizations, which is that IAM segregation of your accounts, to provide centralized policy management, you can use it here as well in the Firewall Manager. One of the cool things is when you've got all these logs coming in and you're in a highly regulated industry like banking or healthcare, you've got to provide some compliance information. And this Firewall Manager, because it's going to aggregate so many pieces of information, it's going to give you good information. And it typically protects resources when they're created and making sure that things are there, so helps remediate things whenever possible. It can also deliver what's called an event-driven notification. So it sees something, it doesn't like something, it can send you a message so you can be brought in to deal with it. So how do you set this up? You enable the AWS Firewall Manager, you define your policies, you apply your policies, and then you monitor for compliance and automate any kind of notifications you want on remediations. And there's going to be a lot of these services we talk about. Let's talk about AWS Config. AWS Config is going to be a service that's going to enable assessing, auditing, and evaluation of your configurations in AWS. From the perspective of AWS, it's going to provide an opportunity to see changes were made. So who made them and where were the changes made? And that's actually going to be some pretty important information to see. Because if you can correlate user A did this and then these logs did this, you can see that what happened and when the change was made. And that way you can say, okay, you might have to train the user and not make a change like that. You may need to change your change control environment for an organization. or your change control process or anything, whatever. But the point is, when you get information, you can make better decisions, and that's really what we're talking about here. So config will constantly monitor all these configurations out there. If a change is made that violates an organization's policy, boom, you're notified. Typically, a CloudWatch event will occur, and an SNS event, you might get a text message, that kind of thing, or an email event problem. So lots of ways to assist with change management. You can track the relationships between things. So this happened, and then this sequel of events happened. Now you know how they're related. Did you plan on that kind of thing happening in the future? Do you need to change your architecture or your configurations or your systems? You'll find these things, and this is going to be very helpful to do so. Integrate with CloudTrail, so you can know what change occurred and then go fix it. So it's constantly monitoring. Configuration change is made, boom, config notes the change. It records it in a consistent format so you can find it. Is it allowed? Okay. Is it not allowed? Go notify somebody a change that was not allowed happened to occur. I hope this kind of makes it a little simpler. You got this AWS config in the center, sitting there, hanging out, monitoring changes, seeing what's going on everywhere along the way. Configuration change is made, boom, it hits the config API. It's sent a CloudWatch event. Maybe you store the logs in S3, but you've got access to lots of information. AWS Inspector. So another AWS service, and it's an automated security assessment service that's going to help to secure security and potentially the compliance of the applications that are deployed in AWS. And it's constantly looking around, assessing for vulnerabilities or deviations from best practices, and it's going to give you detailed reports. Now, there may be times that you're supposed to have a deviation from a best practice and you've got some other best practice deployed, and there's a good reason for it. This is not going to be helpful. It's going to tell you made an issue. But even if you didn't. So understand that these types of services can often give you a lot of extraneous false positives, and that might be okay. They also might miss stuff that's actually very important, but it is an automated service. And it's better to have access to this information. So it is a very good tool along with other tools. So it runs these constant security scans. It'll look at the network, it'll look for common vulnerabilities, and it'll give you some configuration best practices. So these kind of tools are great. By the way, you've got a tool like this inside of if you look in your computer, you'll see a security center. That doesn't mean your computer doesn't need more security than what's in your security center, but it'll tell you, hey, maybe you need new antivirus definitions. Go update them. So start thinking about these kind of findings and recommendations that you're going to get from these kind of tools. You can't secure your entire systems for what you find in your PC security environment center, but it gives you a lot of good information. It can make good recommendations, and it can give you stuff to think about. And then you need to make the decisions based upon the findings that your team finds, organization's business needs, goals, recommendations, what have you, and the unique systems you chose. It can assess lots of things. You can look at the security state of your EC2 instances or virtual machines based upon, what applications did you install? Is your system configured properly? Is the network properly open? It can look at your containers, like an Elastic Container Registry, and it constantly can scan for vulnerabilities and unnecessary exposure, network exposure, say, in your container and images. It can look inside your Lambda functions and scan for vulnerabilities or unintended network exposures. It's got some predefined rules packages. So it has a set of built-in rules based upon common security standards and best practices. It can do some benchmarks whenever that is appropriate for securing operating systems. It'll give you some general guidelines and best practices, and it will provide some kind of runtime behavior analysis. So if it sees things that it doesn't like, it can also be indicative of a system compromise. You can get some fairly detailed findings here, lots of reports, severity levels, impact, and it'll give you some recommendations for what to do. It integrates nicely into any of the AWS security features because it's an AWS proprietary product, which will integrate nicely with other AWS proprietary products. That's the benefit of staying inside of a single provider. So where would you use this? Vulnerability management, here's a good tool. Constantly scanning your systems and giving you some potential vulnerabilities your systems may have, and even some recommendations on what to do about it. It helps with your compliance and auditing. So if you've got to support, say, PCI DSS or HIPAA, and you've got something that's telling you, yeah, you're doing it right, it's going to help your compliance. It can help with your application security because it can make sure that the applications are deployed securely by constantly monitoring. It can detect misconfigurations and vulnerabilities. So it gives you a lot of information, and it can help with consistent monitoring of your systems. Assess your CI/CD system for applications, the DevOps stuff. Monitor new vulnerabilities, misconfigurations, and help you do it. So pretty easy to set it up. Basically, you define the resources that you want to be assessed, like an EC2 instance or a container image. You run your assessments, and you usually use a predefined rules or customized rules, what have you, to run these things, and you schedule your assessments. You review the findings of the assessments, and then you remediate issues as appropriate, meaning you look at their assessments. Is it the right thing to do? Is it the wrong thing to do? If it's the right, go do it. If wrong, it's then you know it. Well, at least you know you saw it and you looked at it and you choose to do something different, which is totally appropriate in many cases too. Some best practices here are to run some good regular assessments and integrate this into the CI/CD pipeline. So you're going to consistently have some better application security along the way. Prioritize high severity findings. If these findings are accurate and they're right, organizations don't have enough resources, generally speaking, to fix everything. Start with the highest priority ones first. Or organizations can choose what their highest priorities are. Integrate it to the security hub, so you've got a good centralized visibility system to be able to look at things. Use it to aggregate findings with the security hub. Okay, I think now is probably a great time for us to take some questions and see if there are any. So Tyrone, let me know what's going on the question front. How to integrate application with RDS via IAM or application users. So there's going to be a lot that goes into this, and your question actually could be answered in one of like 30 or 40 different ways because there's a lot of information more to answer that. But realistically speaking, for IAM authentication, you're going to use roles and policies. For the application, you're going to create a user for, say, the database or whatever needs to be in there. But I don't really completely understand. So your databases can go, for example, could go look at the IAM systems, which are going to go back to, which will typically go back to Active Directory via a federated IAM. But you're also going to have one application that's going to connect to another application. So there's going to be typically an API between them that's going to be part of the integrated of the application. So there's a lot that's going to go into that. And to truly understand your question, we need to speak live, and to answer it, we'd need more than 30, 45 minutes to do so, getting into that part of application architecture. So generally speaking, there's an API between your different applications. And all of these applications have the ability to go look into any type of IAM system, such as Active Directory. And whether it's your routers, like the firewall in my house, I have one firewall that I use as a VPN concentrator. I can have a database on that firewall. I can sync back to, say, a Radius, which is a remote access system to find usernames and passwords. Or my firewall can go integrate into Active Directory to see that when Sally VPNs in and Sally enters her username and her password, Sally's allowed access to this one subnet. So typically speaking, any major application is going to have its own way to integrate into IAM. But in many cases, we're going to be dealing with custom applications, like an application server going into a database. And that integration is over an API. But also, you're also going to have your credentials here, which are typically going to be done on the databases themselves, that are going to go from the databases back into either AWS IAM through an API of some function, or they'll be going into Active Directory, and it knows how to send those right requests. So typically speaking, there's an API involved whenever you integrate one system to another. But there's a lot more to your question that I can't typically understand based upon the way it was asked. What's the best security practice? So there's no such thing as best, ever. We have to look at the organization's needs, and then we need to find out what they're protecting, and we need to understand the value of what they're protecting, and then we need to find a protection strategy. And sometimes a protection strategy is buy insurance on it and transfer the risk to somebody else. So we need to understand that. So let's say I had a web application for a bank. Just for that web application, I might have a network load balancer in front of two next generation firewalls from, say, Palo Alto, and allowing only port 443 into the DMZ subnet. But on the way into that DMZ subnet, I might have another network load balancer, which is going to go then front end to different next generation firewalls from a different firewall manufacturer. I might actually then have another network load balancer in front of two IDS IPS systems inside of there, and then have an access control as protecting that subnet, and then actually have a security group protecting the load balancer where those servers would be. And then on those servers themselves, not only we harden the operating system by coming up with a hardened operating system by removing unnecessary services, putting some anti-malware protection, putting a host-based firewall on it, really locking that system down. And that system itself, still isn't going to be enough. We're going to have to encrypt the storage on that. And then we're going to need to, when somebody tries to log into that system, hit a good single sign-on, a very good, say, Active Directory database. And then for that particular user, because we're dealing with money, we might actually have to use a one-time password, like one of those RSA secure ID things, a password that changes constantly. That's a bank, and that I didn't even cover half of the security. That's just a percentage of the security. But another business might be different. Another business might be just a small business, and it might be a small business that's got a website. A business that's doing less than $1 million a year would be considered a relatively small business. And that company might just need that web server, and it could be a server where they just harden the operating system and put some endpoint protection on it. It can be behind a load balancer. That load balancer may just need a security group and WAF, and then Shield and a content delivery network, because that organization's assets they're trying to protect are very small. And that would still be two appropriate things. And then have a good identity access management strategy. But you can see two different scenarios require two different things that are very different. So I'd like to maybe have you think about it this way. What is the best airplane? Well, if I'm going to go a short distance, they have these Embraer jets that are pretty fast at like 550 miles an hour. They put 50 people on them. They're quick to get on. They're quick to get off. If I'm a fighter pilot, I want a plane that can fly at 3 times the speed of sound and has as many weapons as possible and is still agile. Now I'm taking a long haul flight between New York and Abu Dhabi. Now I want to be in a big, comfortable plane that's got a long range so we don't need to stop for fuel. By comparison, if I was trying to dust a crop, I might want to use a Cessna. So the key is we need to understand what we're doing. That's why there's never a best tech. That's why there's never a best solution, because every business will have unique needs. But it's a great question you asked, Umar. Incredible. CloudTrail and AWS Config. How are they related or different? So CloudTrail logs API calls, whereas Config tracks your resource configurations. So CloudTrail is really for auditing, because it's that auditing side of it. But one is more looking for what happened. Will this system access this system via an API call? It happened 15,000 times. CloudTrail is going to give me that. Config's going to look and say, oh, this operating system isn't the version we think it should be. Wait, you misconfigured this on this server. So it's a really great question, and I hope that actually answered it. A lot of these things are really similar. Like, a lot of them are so similar. And when you think about them, it gets pretty challenging, like the Secrets Manager versus the Systems Manager parameter store. And typically when you see this kind of environment, we've got multiple things that are pretty similar. You typically had a customer in an environment that said, I like this, but I really need it to be this. And all of a sudden they come up with a new service with a new name. And this is common amongst all kinds of technology vendors. Somebody asks for something, you make them something custom, and it's a brand new name. And it's typically similar, but in this case, the one is on the API and one is on the configuration itself. Great questions. So I want to know you're awake, alert, and oriented. So to do so, give me a hashtag that says hashtag AWS. As soon as I see them come in, I know you're awake, alert, and oriented, because now we're getting deep into AWS stuff. And we're coming to a lot of services, much less architectural discussion here. So it's a little more challenging to get through. So I want to know you're awake. If you just joined us, we've got a series of labs for you to do. They're completely free. There's over 40 of them. Sign up, go get them, and go do them on your own time. We have 3 hours a day for 9 or 10 days to do the course, so we really try to give you a lot. If you're having a good time, hit the like button, subscribe, hit the bell to be notified of new videos. And they're there. And we'll take you from there. So let's talk about the AWS Audit Manager. So the AWS Audit Manager is a tool to assist you with auditing your AWS architecture. So it's going to help assess risk compliance with industry regulations. It'll collect evidence to help you be audit ready. It will audit against a pre-built framework. So there's lots of frameworks like ISO 27001. That's a pretty stringent framework. There's the PCI DSS framework. There's the SOC 2 framework. There's the HIPAA framework. Europe has their GDPR framework. And that enables you to customize various frameworks to or create your own to meet whatever audit requirements an organization needs. The key here is its automated evidence collection. It constantly is collecting information from your AWS resources and your AWS services. It'll integrate into AWS Config, which we talked about. It'll integrate into CloudTrail. It'll integrate into CloudWatch and any kind of AWS services that are going to be necessary to get whatever the necessary information is. It's going to provide centralized evidence storage. So one place you're going to go for stuff that's been collected over time. And that's going to make it easy when auditors come in and say, I need to see this. You can run custom assessment reports with this. So your organization wants to go look for this, it'll go out there and do it. So you're probably still going to need to have people that are going to come in and do these things, but it's going to streamline it. When people come in and audit, here's all the information we have, as opposed to them trying to figure out along the way. So it's going to reduce and lower cost audits for organizations that need to audit their systems. Kind of helps with workflow management as well. And it's going to support collaboration between different stakeholders that are involved in an audit process. And there's lots of people that come in, typically from a consulting firm, to do this. It helps manage the tasks, assign responsibilities, track progress. Integrates nicely with third-party tools to check for extra functions. It's going to support evidence and exporting evidence and reports to other compliance and risk management systems that you may be using in the enterprise. Now, when you're under a regulatory environment, you have to do a lot of stuff. This makes it a lot easier when those internal auditors come in constantly and the certifications that come in constantly. So that's one place where you would use this. Here's another use case. You're going to do your own internal audits to assess compliance with internal policies or standards or security. It'll help you identify and mitigate risks associated with non-compliance. It'll help with risk management because it'll enable you to constantly monitor and assess risks that's going to be associated with your AWS environment. It helps you implement protective measures because if you understand what's being there and you understand challenges and risks, you can figure out, I need to do this now. So pretty helpful like that. Now, if you're going to deal with a vendor, you got to audit their stuff. If you allow another vendor into your systems, they can cause you problems. For example, CloudStrike was integrated into the Windows kernel and could make changes to the Windows kernel. probably part of the system where you really don't want to give access to that away. But they had to legally because of another provider in Europe said you must allow access to the kernel. So a third party comes in, it pushes information to Microsoft Windows systems, and all of a sudden they're all crashed and half of the world is down. So whenever you deal with a third-party vendor, you have to audit their stuff. Are they good enough? Are their processes and procedures good enough? Are their controls good enough? If not, you stop doing business with that provider and you do business with another provider. But the reality is you're generally going to use multiple providers anyway, so you're not stuck with a single one and their vulnerabilities. But that's the key. You can use this tool for vendor and partner audits, and that is very critical when you deal with third-party vendors. Let's talk about another security service, and it's called the AWS Certificate Manager, ACM for short. So lots of times you're going to need certificates, right? SSL, TLS certificates on, say, web pages. And where do you get it? You get it from a certificate authority. So AWS has that certificate authority functionality to be able to give you certificates when you need them. And they can handle automatically, the certificate renewals, and integrated very nicely into your AWS services for your website, your applications. So enter the world of the AWS Certificate Manager. It is an AWS managed environment that enables you to centrally manage and take care of your certificates. Makes it easy to provision a public or a private certificate. Public certificate is stuff you use on the internet. Private certificate is things that you might use internally. Maybe internally, you've got an HR system that's accessed over the private internet over HTTPS. Well, that would need a certificate. Doesn't go to the web, though. So that would be an internal certificate. And Certificate Manager will give you free public certificates to things like AWS APIs or load balancers, but you're going to have to pay for a private certificate. So we're going to use certificates everywhere, but in this particular case, we could be using the Certificate Manager to create certificates. We might put an SSL TLS-based certificate on our CloudFront distribution. We may put it on the load balancer that's in front of our web page, terminate some SSL sessions there. And that's kind of really what we're talking about with the Certificate Manager and where you might use it. Let's talk about some key features of the Certificate Manager. It enables you easily to provision certificates. And it's simple. You go to the management console, the CLI, or via an API call, get your public or your private certificates. It automatically renews your certificates before they expire. So continuous protection over your certificates. And that's going to make it a lot easier than installing certificates. Okay, we've got to go to all 15,000 devices and then remove certificates and add a new one. So big help there. Because it's an AWS thing on AWS, it's going to make it very easy to integrate with any kind of AWS services like a load balancer, CloudFront, an API gateway, Elastic Beanstalk, what have you. And it's going to make it relatively easy to at least provide TLS, SSL, TLS-based security to your applications like your website. You can use it for domain verification as well. And you're going to use domain verification to verify domain ownership before it's going to give certificates to kind of lock that down to make sure they're supposed to be where they're supposed to be, by whom. And it'll offer an email validation as well to make sure that the domain is who they are supposed to be and ownership is exactly accurate and legal and right. Let's talk about centralized management. It's going to provide a centralized interface to manage all of your certificates, whether they be public or private, and that's going to make it easier to track. So where might you use this? Secure web applications. HTTPS needs TLS-based certificates. API security. You may need to secure your APIs with a certificate to guarantee that the receiver is who they claim to be and the API is who they claim to be. So you can use it for API security. You might use it on internal applications. Maybe you've got a database or an internal application like an HR application that you need some security on. So you can use a private certificate internally, accessed over the private network in the internet, not the internet. You can use it with compliance and governance because you can ensure that these certificates are going to meet security standards and that you're using SSL or TLS as needed to maintain compliance with your industry's privacy standards. So how do you use it? Pretty easy to set up. You go to the management console, you navigate to the certificate manager, and you request a certificate by clicking it. You choose whether you want a public certificate or a private certificate. You enter the domain names, for example, gocloudcareers.com. Then you validate the domain ownership to make sure that you do own the domain. It can do a DNS validation by asking you for a CNAME record to your DNS settings. It can do an eName validation, realistically speaking, to approve the verification request by going to a domain registered to the user. You deploy your certificates by putting it on the load balancer, CloudFront, your API gateway, what have you, and you monitor and review. And it's going to automatically renew your certificates before they expire, and it will monitor the certificate status, and you can do so by looking at the ACM console. Some best practices here: use DNS for automation. It's going to be harder to fool DNS in most cases than it will be a simple email. So prefer DNS for validation because it allows for a quick and an easy and a relatively secure validation. You just update your DNS records as needed for automated validation and renewal. Leverage the certificate manager for managed renewals. If it's got the ability to automatically renew them so you don't have any downtime because you didn't renew them on time. Because you don't want people to come to an application and get that this page is unsafe. That's not going to build any trust with your audience. Centralize your certificate management. So if you're all on AWS and you want to use this AWS Certificate Manager, it's going to be very simple. And it's a great certificate manager. And you can use it to track and the audit of the certificates across your AWS environment. Make sure you use it to secure internal communication. So if and when possible to use a private certificate inside of your network, do so. And that way, if something's no longer good, you can revoke that certificate and as well. And of course, obviously follow security practices. So use strong algorithms, encryption algorithms, and ciphers. Update your SSL TLS configurations. Make sure you're adhering to the most appropriate security standards. Okay. Now, another AWS security service. I'll try not to spill more water on me. Here's Guard Duty. So Guard Duty, AWS Guard Duty, is a managed threat detection service that kind of looks around and consistently monitors your attacks, monitors your account, your workloads, any kind of information you stored in, say, S3. And it's kind of this behind the scene things, kind of using machine learning to look for anomalies and things that doesn't feel right. And then it's going to use some threat intelligence to say, this is probably a big deal. This is probably no big deal based on AI. It's a service that'll help monitor your accounts. It'll look at your CloudTrail systems. It'll look at your DNS. It'll look at your VPC flow logs. It'll look for patterns of behavior with compromised systems. And if it sees something, it might send you a CloudWatch event to notify you of something so you can fix it. It's here for threat detection, kind of looking for stuff all the time. It's looking for anomalies and suspicious activities. Now, each day periodically there's what's called threat intelligence feeds. And there are companies that basically like Proofpoint or CrowdStrike that basically provide a feed. Hey, these are all the threats we know about today. So that'll integrate into them. It'll constantly monitor your AWS CloudTrail, your VPC flow logs, DNS logs, that sort of thing. It can look at your CloudTrail. Again, these are your data sources, VPC flow logs, DNS query logs. And then it uses that pattern matching anomaly detection to say, this is not something you think. It's deviating. It could be a problem. So it gives you detailed findings by severity, low, medium, and high. It gives you some context for each finding. And it's going to integrate with the AWS Security Hub. And it can help automate your remediation. And here's the good news. It can connect with your third-party SIEM system. So in a big global enterprise, you're going to be getting logs coming from something. And you're going to be dealing with these comprehensive SIEM systems, these security event monitoring systems. You're going to be constantly looking for these things and potentially across 2 and 3 clouds. But this integrates to those types of systems. And to some degree, it provides similar features and functionalities, maybe a little different. And one good thing that you can say where you might use is it'll help really find if your account's been compromised. It may look for unusual API calls or too many login attempts. It'll look for unauthorized access or attempted privilege escalations where you go from a regular user to, say, administrator or trying somebody with administrator privileges. You might use it for protecting against data loss. So organizations typically have a data loss prevention strategy and systems to do this, but this can help with look at your data as well. For example, it might detect an abnormal data transfer between 2 different locations and send you that maybe this isn't supposed to occur. It can look at unusual patterns of data or access to transfers within S3 buckets. Should this bucket being compromised to somebody else? It can look for malicious activities fairly well. It'll provide alerts on known malware, bots, and other threat actors. Now, it'll monitor for signs for command and control activity. But see, the other thing here is known attacks. Known attacks are good, but some of these more enterprise things can look more closely at unknown attacks as well, meaning that as soon as it happens, something is abnormal. And sometimes you need that, and sometimes you don't. So where might you use this? Well, compliance and governance all day long. Anytime you can tell a regulator, look, we've got all these audit trails and we got constant monitoring, it puts you in a better way, especially if and when things go wrong. Because you can say you followed best practices. Regularly, you should monitor these things. Regularly, constantly look at it. What's it telling you? Is it good at giving you good information, bad information? What can you learn from it? You want to consistently monitor for new patterns of updates and threats from threat intelligence feeds. It's going to help you automate responses, and you're going to use it for this. So implement automated responses. Define clear workflows for incident response and remediation. Integrated into AWS Security Hub or more commercial, more robust SIEM tools and any other kind of security solutions, because security is not about one tool or 2 tools. It's about the entire package, because there could be hundreds of tools going on for security inside of an organization. And Guard Duty could be one that you could use. Now, whenever you use things, in best practice wise, there's always a user training and awareness component. I'm going to go out there and educate users and administrators on common security threats and best practices. You want to make sure you encourage regular security training and go out there, because you can have the best systems in the world. And if you don't train your people, don't click on that button, don't give out this information, or know the CEO did not ask you via email to go buy Apple gift cards, they may fall prey to some of these scams. So how do you set it up? Well, you go to the management console and you select Guard Duty and you select Enable. And right around there, Guard Duty will automatically start monitoring your AWS environment. Then review the findings. Go to the Guard Duty dashboard and look and see what it tells you. If it's got a high severity finding, go look at it. Is it valid? And if so, maybe you need to fix it. Maybe you can't fix it now, but you can soon, and you'll plan to fix it, but do what you can based upon what you see. Whenever possible, set up automated responses. Maybe set up a Lambda function to go remediate it. User put an object in S3 and made it public. Kick off a Lambda function to fix it. It's the most common cloud attack, because somebody did that in S3. So with Guard Duty, it notices, it monitors it, kick off a Lambda function to go fix it. Integrate it with Security Hub. So the point is, all these tools are gathering information. If you can aggregate it in one place, you might look at it and be able to do something with it and figure it out, because it's very, very hard looking at all kinds of stuff all over the world. So now we're going to talk about Amazon Fraud Detector. And that's going to be another managed service. It's going to help you identify potentially fraudulent activities in real time using AI or machine learning. And Fraud Detector really automates the process of building, deploying, and managing fraud detection models. So it helps you detect online fraud more accurately and efficiently than you may be on your own. So how does it work? It uses machine learning. So AWS has these pre-built models which it feels are optimized for various type of fraud detection services, and they've got some experience there. So realistically, these systems are going to work. And that makes it easier because to make a model, because you've already got tailored models to detect fraud based upon the preponderance of use cases. So, you may need custom, you may be able to get away with this. And it's got fairly customizable rules, so it enables you to define custom rules to supplement whatever the machine learning models they're using are. It enables you to provide an ability to look at your business logic and tune this to make sure it looks at your business logic to enhance the fraud detection. And then it will real time go look for problems. It'll integrate with your applications via APIs. It'll look at transactions, and it's going to give you that real time prediction. Enable you to look at it and say, normal, abnormal. Big response in the market causing this. So this is normal today, but not normal another time. So good information. And the more of these systems you get, the more you're getting. It enables what you would think of as data enrichment. So you're pulling all this information. If it can make accurate information, recommendations, and insights, it can help you make better decisions. It's going to use metadata so you can look through the data and find it a lot easier. It's going to help with your scalability because it's going to scale automatically to handle large volumes of traffic. And that way you're going to have some relatively good low latency and high performance fraud detection, basically pre-made that you can use with the service. And it's integrated into so many AWS services. So as long as your stuff is all AWS, you've got fairly comprehensive workflows, it's going to be pretty helpful. Where might you use this? E-commerce fraud. In e-commerce, you may detect fraudulent orders or things called account takeovers or payment fraud. And, what happens is businesses will take a credit card. Somebody will buy something, say a $10,000 computer. They send out the $10,000 computer, and then somebody finds out that it was a stolen credit card. And what will happen is the bank will pull that payment from the vendor, but the vendor gave out that $10,000 computer. So that e-commerce would be probably an reason a business might choose this. Financial services. Well, they typically have very good fraud detection, but systems of their own. But this could help there too, because it could look at fraudulent transactions, weird account opening, identity theft. That stuff happens all the time, sadly. And it can enhance an organization's operations, financial-wise, and trustworthiness and security. Insurance fraud. It can detect all kinds of funky claims with underwriting activities and insurance. It can improve risk assessment, and by doing so, reduce the cost of fraudulent payouts. Insurance prices go up and up and up and up because they're paying a lot of money, and then they pass the cost on to the users with insurance rates that in some cases people can't afford. So if they can mitigate fraud, they can keep insurance prices at a reasonable level. How about gaming? Online gaming, subscription services, digital content platforms, another place where you may want to use some fraud detection. So how do you set this up, this Amazon Fraud Detector? Well, you prepare your data. You're going to have to collect historical data and label them as fraudulent or non-fraudulent. Why? This is going to enable the system to look at the data and learn, oh, this is acceptable, this is not acceptable. So your data with any AI becomes your course of truth. Meaning if your data that you give it is bad, your results are going to be bad. So you're going to make sure you've got any kind of good information that you can feed this thing. So the first thing that we do is we prepare our data. The second thing we do is what's called creating a detector. So in that management console or the CLI or the API, we've got to go create a new fraud detector. And we're going to go configure that detector by specifying the data set and defining the model training parameters that we choose to use. We'll then train and evaluate the models. We'll train the fraud detection using whatever prepared data we gave it. We'll look at the model's performance. Is it working? Is it accurate? Is it precision? If not, we may need to retrain it or look at our data and clean up our data to make sure our data is good. Then we need to define custom rules and outcomes. So we're going to have to create that custom logic of what we want it to be. How do we want it to enhance? How do we want it to detect? What actions do we want it to take when it sees something that's suspicious? Do we stop the action, for example, but what do you want it to do? And then we deploy it and integrate the model. And of course, we deployed it, right? So we go back and monitor. So, the Air Force has what's called an OODA loop, where you observe a situation, you detect what to do. So observe. So was it observe, orient, decide, act? I think that's how they observe. Yeah, you observe something, you orient yourself, you make a decision, you act. That could be one kind of thing. But in medicine, we start a treatment. We assess the patient. We bring them back into the office after a couple of weeks. You're getting better. You're not getting better. Here's a new prescription. So anytime we deal with anything, we're going to build a plan. We're going to deploy the plan. And we're going to test and see what worked and didn't. And then we're going to modify and change. So keep this in your mind. Nothing's ever going to be set in stone. Let's talk about some best practices for Amazon Fraud Detector. First, use good data. If your data is bad, your results will be bad. Regularly update your data set with new transactions to keep the model current as things change. You got to bank what, when I was younger, something, gas was $1.25. So it was normal for people to spend $10 on gas. And in those days, if somebody spent $100 at a local gas station, it would have set off an alert. But now, if gas is $3.50, $4 a gallon, and your car takes 25 gallons, you spend $100. Now, if you didn't update your data between then and now, all these systems would be bad. But even 3 years ago, we had $2.50 gas, and now it's like $3.50, $4 based upon where you're at. So that's a big change in a very short period of time. So you have to update these systems because they might not know what's normal now versus abnormal as data changes when they change by a lot or a small amount or even a medium amount in a short period of time or a medium period of time. So combine machine learning and rules. So use a combination of these machine learning models and custom rules to enhance your detection and your accuracy. And then leverage these information for specific business insights to make sure that your rules are effective. Monitor the performance of these systems. So constantly monitor the performance of your new fraud detection system. Use feedback loops to retrain your models or refine rules based upon new fraud trends. Test and validate. Rigorously test long before you deploy them. Don't just deploy stuff at speed, just to say you did and figure it out along the way. Test and really make sure these systems work. Conduct some A/B testing to compare the effectiveness of different strategies. Which one works better? Let's talk about another system, the AI-based, AWS Macie. And here's what my plan is. My plan is to go to about 4:50, 4:55, and then take questions, even if we run about 15 minutes late. My wife has some big plans for me on Friday if I can finish on Thursday, and I want to make her happy. So I'm going to try to finish on Thursday by going a few minutes late each day. And if we can't, I will just tell my wife I can't do it, and I'll find another way to make her super happy. So let's talk about AWS Macie. And that is a fully managed data security and data privacy service that, again, uses machine learning. And the goal here is to look for patterns of behavior that are abnormal and protect your sensitive data. So you may actually get notified that you have sensitive data on the system, like personally identifiable information in your S3 bucket. So it's going to do some automated data discovery, and it's going to constantly monitor and scan your S3 buckets to identify your sensitive data. And it's going to look for various patterns of what it sees as private health information and financial information or regulatory data. And that will help you meet security and compliance by identifying your data, security, and it's going to give you some fairly detailed reports and dashboards for compliance reporting purposes. It's going to give you relatively detailed finding and alerts, which, again, it's machine learning, so some of it might be great and some of it might be not. And I can give you an example later if you guys desire. And by guys, I mean everybody, men, women, just general blanket term. So some things to think about is it's integrated with everything that's AWS relatively easily. So CloudWatch, Lambda, AWS services. And it's going to go out there and it's going to look at stuff and look at your S3 buckets. And then it's going to go prevent data breaches and look for unauthorized access. So where might you use this? For compliance purposes, it may look for things like GDPR or HIPAA. It may provide audit trails and compliance reports. You might use it in risk management to identify misconfigured S3 buckets. It's great here. You might give you some data privacy management. It's going to look for things like personally identifiable information. It will support privacy assessments and data protection strategies. And it's going out there and it's looking for what it thinks is sensitive data. And it'll do what's called a data discovery job, and it's going to constantly scan your S3 buckets, and it's going to give you a detailed report. So let's talk about some best practices. You got to constantly monitor this stuff. Constantly look at it, review it, and update it. Prioritize high-risk findings, because some stuff is terrifying and you better fix it immediately, and other stuff you can leave for a long period of time. Automate the remediation. So automate it with the Lambda function and integrate it with Systems Manager. Integrate it with Security Hub so you've got a centralized view. Look for custom data, set up customized data identifiers. Tell it to look for something specific in its data discovery. Tune it, tailor it. So how would you use it? Well, first, you enable Macie. 2, you'd go to the data directory and configure it to tell it what data to discover. Set up this data discovery. Scan your S3 buckets to how often you want to scan them, that sort of thing. And review your findings. So to give you an example of these types of services, one day I was sent a message from Google that I had ICD-10 diagnoses codes. And obviously that would be something you wouldn't want to share. And an ICD-10 diagnosis code is a couple letters with a dot and a couple more letters. So I got an alert that I had ICD-10 diagnosis codes in my Google Drive, the corporate Google Drive. And, I was thinking, did I see a patient as a volunteer? Could they have been right? Did I write a diagnosis code or a procedure code on a patient and store it in object storage by accident? So what we did is we scanned it, me and Chris from my team. And we saw that I had an IP address that somehow was broken down, 192.168. And then I had another thing right after it, which was another half of an IP address, but they were separated. And it looked like an IC10 diagnosis, even though it was an IP address that had one accidental space in there. But these machine learning looked and they look at it, oh, that looks like an ICD-10 code, and they sent an alert. Now, it wasn't there, but that's the thing to remember with these automated systems. They're going to send an alert, and it might be great. It may be horrible. So we're going to have to constantly go through these things. So the next level of content is a big new topic. It is IoT, and maybe I save that tomorrow. So, Tyrone, who has questions for me? Because that's a a lot of concepts. In AWS, can you use one SSL certificate for all services? Unfortunately, not. So the key with an SSL certificate is for me to know that you are in fact FA, as opposed to somebody else. So I'm not part of what part of Cameroon you're at. So I do remember you said you were in Cameroon. So Eddie from my team is in Bamenda, Cameroon. So here's the reason we use these certificates. Let's say I wanted to talk to you and we had a conversation, but I never met you before, like a web server that I've never seen. And Eddie, who's from my team, Eddie's a rock star. He's awesome. I think he's got a degree in law too. He's super smart. He's a great cloud architect. But if I wanted to talk to you, how do I know that you are Fa as opposed to you being Eddie? I don't until I validate, the endpoints of your digital signature or your certificate. So every device that needs to be protected is going to have a different certificate. So, you might need a lot of them. And especially if we're going to use encryption in certain types of zero trust environments. And zero trust is basically identity access management and encryption and micro segmentation. But if we truly wanted to issue a certificate for 1.5 million end devices in an environment, in a pure, heavy, ridiculously grade zero trust environment, we might need 1.5 million certificates. So each device, each system is going to, or different service is going to require a new SSL certificate. Great question there. So how can we integrate AI with AWS services like RDS data within the databases? So in reality, it's not just going to be a simple integration. You're going to have to go look at that business and determine what are the business's goals. What are the business pain points? What are the business challenges? What are the current business processes or the way things get done? How do we want that to occur in the future? What does that organization's network look like? What does their compute look like? What does their storage look like? And what is the quality of their data, the quality of the databases? What are the mapping and reduction tools we have? What are the data hygiene practices we are? And from there, we can figure out what we need to do to the data. Then we will need to pick an AI model. We will need to train that data. And there's many other things that are going to go into it. So wasn't planning on bringing this up. So I actually have an AI architect program. And that is a big program taught by someone I have a lot of respect for. His name is David Lithicum, where he actually teaches how to do this because he's been in AI architecture since the 1980s when he first did his first AI program and then was working for NASA as an AI architect. And then he spent, time as chief technology officer and chief cloud architect, where every project has been AI for like 30 years for David. So I have David teaching that in our AI architect career development program. And if you'd like to learn about that, or those things that you need and the skills, there's a free video on our YouTube channel, or you can register for a free webinar. So there's that. So the easy answer that I could give you that would be part of the certification would be, here, just use AWS SageMaker. And that's going to analyze your data that's stored on your RDS, and you've got lots of models, and you can pick and choose from your model. But the real answer is it's going to take a whole lot. Do we have the right kind of storage? Do we have the right kind of network performance? What kind of model do we need? And what kind of compute does that model need? Is that model something that can run on a CPU? And many models can. Do I need a GPU for that model? How much DRAM do I need on the compute to do this? How many GPUs do I need for the training data if I do need GPUs? Is it going to be done on CUDA? Most likely, which means I need an NVIDIA GPU. Is it not based on CUDA, where I can use an alternative provider GPU that's a very good GPU if it doesn't need CUDA as part of the compute that we're going to be using? And AWS and NVIDIA GPUs are great. I'm just saying, is it something that can be run on an FPGA because it's standard data? So all that's going to go into that before we can answer that single question. But yes, you can definitely use it. How do you use Lambda functions to automate remediation? So what you can do is it's basically you'll design what's called an event-driven architecture. And what it will do is, if this, you will write a little mini application, do this. So if Mike uploads something in the bucket as public, and you've got an event-driven thing that says, as soon as you see something as public, kick off Lambda function 123 that says make private, you can do that. So that's the way these things are typically done for automated remediation. You write a code, or it's a very, very simple script. So we're not talking about fancy code here for these kind of things. We're talking about very simple scripting. If this, do this. So the example I would give you was many, many years ago. You would log into a Cisco router, and then in order to do something, you had to type in, and it would ask you for a username and password, which would go to an IAM server like Active Directory or Radius or TACX Plus or whatever you had. And then when you'd get on that server, you'd click enable. And that would give you the ability to do something. And then it would ask you for an enable password, which was privileged executive password. And then you'd try to do something like configure. So you'd type config T to configure the terminal. And it was a standard set of procedures. So what we did is we had our sysadmins write something called, like, there was a language called expect TCL, expect username and password, send username and password, expect this, respond to this. So it's a very simple script that people are writing that are going to do these things. If public, make private. That's really a great question out there. You're in Colorado. I think it's terrific. What's the weather like today? I was always amazed in Colorado. I'd be freezing and then I'd be hot, all in the span of 10 minutes. It was really kind of cool. So there are no questions. So I can kick into, if you want, and we'll probably have Friday off, spend, say, another 20 minutes and kick off IoT devices, or we can finish on time. What would you all like? I'd like to try and get done on Thursday, but that's just me. You tell me, let me know what you guys think. Go a little longer or stop now? You see what you say in the chat box. George Lopez says, let's keep going. He was the first one to say something. I haven't seen any responses. Can go a little longer from Prasad. I love it. Let's go for a few more minutes. Information overloading. I'm sorry about that. So let's get one or two more. I think we go for a few more minutes. And then what we can do in the future is you can go back and look at it and go back and watch the last piece. True about Colorado. So let's go through it. I will stop by 5:20. So let's talk about IoT, or Internet of Things. So Internet of Things are like your little mini refrigerators that are IP enabled. Your TV that's IP enabled. The lawnmower that you have that tells you I need to be managed is an IP enabled Internet of Things devices. So weather sensors that are out there all the time are IoT sensors. So there is so much of these things that are out there. So typically speaking, you've got these little mini devices. These little devices are attached to the IP network. They send beacons, they send their information, and you're going to need something to manage it and retrieve it, and then you're going to need the devices themselves. Did we talk about a control plane versus a data plane before? Did we talk about the control plane that orchestrates the cloud and the data plane being the servers that are there? Have we talked about routers that run a routing protocol like OSPF and BGP, or sometimes both, for example? And then the forwarding plane, which are those links. Did we talk about Kubernetes master nodes versus the pods? Are you getting a theme here? All this stuff is the same. Learn it once under the foundation, and you'll be good to go for everything. So we'll begin talking about AWS Web Services IoT Core. So what is that? That's going to be a managed cloud service that's going to enable connected devices to securely interact with cloud applications and other devices. So the IoT devices that are out there, like your refrigerator, which talks to you and texts you when you're in the supermarket, that says, buy more broccoli, for example. I don't know. I eat a lot of broccoli, but that's neither here nor there. So that kind of thing. So it's designed to handle a lot of the complexities of IoT, things like the connectivity, things like the security and things like management. So we'll begin with IoT Core. That's going to be the part that's going to help the building of IoT applications that are going to gather, process, and analyze, and even act on the data that's generated by these devices. And you might have a weather sensor every 5 miles across the entire United States. It could be, lots of these things. So IoT Core is basically the foundation for Amazon's solution for managing, deploying, and analyzing and maintaining an IoT architecture on the AWS cloud with minimal infrastructure support from the system owner. So normally you got some network architects that are doing these kinds of things. Here, it makes it a lot easier because a lot of it's semi-automated, helps you with doing it. So AWS IoT Core is going to provide a scalable and AWS maintained solution that's going to supply secure connectivity from devices and to the devices. It's going to provide some rule-based IoT data traffic manipulation. It can, take command and control of these little devices that are out there by the fleet. So I want you to think about this. You may have tens of thousands or millions or hundreds of thousands of these devices out there. Think about that operational burden. All this stuff out there. So IoT Core can help out with that a lot by providing a platform that's going to support communications and management of these IoT platforms and devices. And it's going to be managed by AWS engineers. So if you don't have those networking people or the sophistication to do it, it's provided for you. And you may choose to outsource this to somebody else so you don't have to think about managing this and can focus on other key business matters or other new products or services to be developed. So IoT Core is going to facilitate communication from the devices to the cloud. It's got built-in authentication and authorization. It can connect to a RESTful API for command and control, for example. It will work and support access control lists and even a device registry so you know which device is in the state of the data connections. So the IoT Core would be a service that's going to be beneficial to any scenario where there's a need to have a lot of IoT devices and you're looking for an easier way to get the information, analyze, and make actionable decisions in a quick period of time. So single device to potentially billions of devices because there's a lot out of it. So let's look at this overall solution. You're going to have these IoT devices all over the place. And they could be connected via the internet. You could be connected. They could be devices that are coming into AWS. And you can send all of that stuff directly to this core IoT. And that's going to expose an API. And then there's going to be a lot of other services we talk to that you can use with this overall architecture. But that IoT Core service in the center, that's the component that's going to reach out to it and really be able to help you with these things. So that is your main thing there. That's the core of it. That is the central. That is your control. At least that's the way I like to look at it and help me remember things. So it's going to enable secure device connectivity. So devices can connect to this using a systems-based approach or a standards-based approach. So HTTPS, WebSockets, and it's going to ensure that the data is going to be transmitted with TLS encryption. It's going to help with device management because it's going to give you tools to register, organize, manage, and even remotely manage these systems at scale because there's a lot of these things that are out there. And there's going to be an IoT device management feature that's going to help you keep track of these devices because you also want to make sure they're working correctly. Now, you may have to use a message broker, and there's this MQTT message broker that's available for you to use to facilitate communication between the devices themselves and the application. And this can handle millions of devices sending constant messages. There's also going to be a rules engine. And the rules engine will enable you to filter and process and route data from connected devices, like various AWS services, whether they be Lambda, S3, DynamoDB, Kinesis, and so many more. And you can define rules that are going to trigger specific actions based upon incoming data, event-driven, if you will. So where might you use this? Well, lots of reasons. But maybe you're going to centrally manage and control smart homes. I don't know why anybody would do it, but I have friends that have thermostats that they manage from their phones and lights that they change colors and security cameras. And here you could use something like this. I don't want any of my devices IP enabled because they can be hacked. But a lot of people love these smart homes. Now, I'm more of the industrial use of these things. So think about industrial Internet of Things. You've got a lot of heavy duty industrial equipment that's out there. When does the backhoe need its oil change, for example, or when does it need maintenance? When does the airplane need to come in for maintenance? When are these trucks that are being used on the road all day? When do they need proactive maintenance? When is some little thing or part going wrong where they need to be coming in and fix it? So think about the industrial uses of IoT. It's everywhere. Tracking equipment, tracking performance methods, metrics, predicting maintenance needs. And you could have all these IP-enabled sensors, and it can in some cases, remediate responses, but you're going to get access to this information. Connected vehicles. So start thinking about vehicles that now have IP addresses. They can give you real-time diagnosis of your issues, enhance your driver experiences, potentially stop you or your car if deemed appropriate. Healthcare. Well, in healthcare, talk about sensors and information overload. But now, one of the things we typically do is, we have patients with congestive heart failure. So we typically weigh them because with a patient with congestive heart failure, if they gain a few pounds, at some point it's fluid weight and it'll go into the lungs and they'll drown with congestive heart failure. So we can have IP-enabled scales where the patient can jump on the scale once a day. And it can send a message to the cardiologist that said patient has gained an unreasonable amount of weight in a period of time, which is usually fluid. Make a cardiology office visit or send a nurse to the home to assess that patient to see if they need to come into the hospital. So lots of uses here for the IoT core and IoT devices. Let's talk about device management. So organizations are going to need to figure out what devices they even have and how to manage these things. So you'd be surprised what companies have and don't even know they have. So IoT device management is another AWS service that can easily register device information. So you can pull their information. How many devices do you have? What's going on? And you might want to remotely update the device's software and firmware. Maybe you found a major vulnerability in the device itself, which could be used as a means to hack into the systems. So that's a big issue with IoT devices. This service will help track and monitor and manage your devices or a fleet of devices to make sure they work properly after they've been deployed. So IoT device management will provide a device manager that provides access. So to securely look at device health, defects that it finds, detect anything or a problem so you can fix it. So let's talk about some things that IoT device management helps out with. The remote fleet monitoring. So equipment itself is going to have a lot of data or metadata, and you can set a policy to be informed of key alerts that you need. You may have to perform bulk updates of a lot of IoT sensors. Maybe you need a new feature or function for some new application the business needs to deploy. And they've got a lot of these already out there. So you can create logical grouping of devices like sensors in the South Florida area, for example, and you can do a targeted fleet and update a percentage of them. So lots of things you can do here. So let's talk about IoT Events. So that's going to be a cloud-based service that's going to continually simulate data from applications and equipment and changes that occur. If something happens, it'll trigger an event, which will trigger the right response to the event. So one of the keys with IoT events is it's serverless, meaning there's no host for you to maintain. It's just going to be out there and monitor data. And if it sees something, it'll give you information, maybe early detection. So you'll have some information, you'll get some insight from it, and then you can figure out what the appropriate action is to take after you've gotten this data. So that's where IoT Events is going to help you. So it'll make it much easier to detect and respond to things. It'll help an enterprise understand the conditions of its equipment, which is really critical. If you're going to trust the equipment, it's better be in good health and accurate. It'll help an organization gain some insights. And that's the key. If you find out that an organization has a fleet of stuff, maybe a global or national construction company, and you find out that their vehicles or tools need some kind of maintenance thing, if you can come in there and maintain them, as opposed to taking them offline for months because they broke, this can help a lot. Find a defect in an airplane before you find a problem, even though you're constantly checking those systems, gives you more information. So we have this concept of IoT Things Graph, which is now called Internet of Things Twin Maker. And what it does is it creates what you would consider a digital twin of a real-world system. So a twin of a building or a factory or industrial equipment and production lines. And it makes it easy to visualize the status and the interactions. What it'll do is it'll integrate data from various sources like IoT sensors, your applications, your data lakes, and it enables you some very good real-time monitoring of the digital twin. So it enables you to simulate various actions and see what happens to predict actual outcomes, which is very cool. And by doing so, you can think about how you can better do things. So the costs here are going to be based on a lot of components like data ingestion, your storage, your processing time, your visualization, what your detection is, and your automation. But anytime you get an ability to have like a twin system, and you can allow a simulation, it can give you an opportunity to game in the system and see what would happen, which is highly useful. Let's talk about IoT Analytics. And that is going to be another fully managed service that's going to allow users to connect, manage, and ingest a whole lot of these information from these globally diverse systems. And it's going to provide a complete solution to collect, process, and analyze all this data. And it's going to help enterprises and device manufacturers quickly and easily get information from their data, maybe some insights, and then they can transform the data and analyze the data to do something with it. So lots of benefits from good analysis of data. So IoT Analytics will look at stored data and give her a relatively fast response on a query to your IoT devices. It can prepare the data so it's easily processed and analyzed. And it can be a managed pay-as-you-go type service that scales with you. So you want to predict maintenance models in your fleet? Here's a solution. Like also knowing when a service is about to fail or need maintenance. Helps you build applications that can monitor your inventories in real time. And it gives you the ability to monitor different processes and different areas of improvement. There's a couple more AWS IoT systems. There's something called Timestream. And Amazon Timestream is really going to be a fast managed time series database. And it's a database designed for these IoT things and the types of operational applications that can be stored and analyze all of these devices because you're going to get lots of information. And the key is that it's time series data. It's data that comes with a timestamp. So you know when it's collected. And here's the reason. If you collect all this data over time and you know the times, you can look at performance metrics or usage data or sensor readings. And Timestream, is going to be a fully managed, auto-scaling, fault-tolerant, cloud-native SQL relational database because you're storing transactions, you're storing time. For the most part, it's structured data, so you'll use a relational database. But Timestream really specializes in storing, trackable data that changes over time. Time series data. What are the analysis and trends over time? So they can ingest, trillions of events over a period of time interval from various sensors and all kinds of things. So Timestream is going to be, a way to look at all your IoT devices, smart devices, motion cameras, light sensors, temperature sensors, health equipment. You could be getting a lot of information. And you're going to be able to look through this. It can notify patterns and trends and anomalies, and that's going to be able to help you make better decisions or better predictions. So the thing to keep about with Timestream is it's managed. So no, basically nothing to think about like databases and patching the operating system. It's designed for time series data. This stuff will happen over time so you can get an analysis of it. It scales. It can handle trillions of events per day, and it's kind of that cloud provider build it and they hope the users come. So lots of capacity here. And it's great with time series data. So what is it really doing? So Timestream is helping with data ingestion. It's going to ingest data from a lot of sources. And then it's going to store the data. It's going to manage the storing of the data and time. Recent data will be stored in memory, like a hot tier. Older data will be in an SSD storage. So you're going to get real good performance to recent data. You query the data with SQL queries. And you will it'll manage your data retention policies and where you're going to keep your data from hot, meaning in DRAM to cold on SSD drives, for example. It's going to give you lots of monitoring and analytics. So next is AWS Wavelength, and that's going to be an edge computing service. So why? So imagine you've got driverless cars that are out there. Imagine you've got all these IoT devices that are there. Many of these things are connected wirelessly via, say, a 5G network. And realistically speaking, we have two options. We can have these devices connect to the 5G network and put servers there and process the transactions right there at the edge of the network, which we do. And sometimes we could backhaul it. So we could connect to the 5G network, and then from the 5G network, create an IPsec tunnel all the way back to our data center, which could be 1,000 miles away. Well, which do you think is going to provide better performance and lower latency? Process it directly at the edge where the users are connecting anyway through the mobile environment, or connect to the mobile environment and then drag it back, say, 1,000 miles away to the cloud provider's data center or your data center. So obviously being closer to the user. So AWS Wavelength gets you closer, your infrastructure closer to the user. So lower latency. So what happens is you're going to see these AWS resources at the edge of the provider's 5G network. So they can be processed directly where the 5G network already is, as opposed to backhauling it to the organization's data center. And basically speaking, wavelength zones are part of the global infrastructure, but you can put your stuff where the 5G networks actually are. So at the edge, they have scalable infrastructure because your infrastructure will scale just like it would on the cloud. And it'll give you all the integrations to your VPC or your IAM or your encryption strategies. And it really gives your developers some flexibility, where they want to use their stuff and when. The key here is that it's available at various locations worldwide. And you're going to use it for gaming, right? So gaming is where where you've got people playing this low latency thing. And if you can get them closer versus back, it'll give them better performance. Live video streaming. Whoa. Video does not is not a big fan of latency. And what it's really not a fan of is what's called jitter, which is variations in latency. So anytime you can reduce the lag or the buffering of video streaming, you improve the performance. So IoT applications like a self-driving car. Do you want that thing going directly to the edge of the service provider's mobile phone network where your AWS stuff is in San Francisco, if you've got a self-driving car in San Francisco? Or do you want to backhaul it all the way to, say, Ohio or some other part of the world? Well, you want to do it locally because you want that car, if it has to hit the brakes, to do it with the least amount of latency as possible. So that might be another place where you use it. Virtual reality, augmented reality. Lower latency feels better performance. Machine learning at the edge of your network. Think about how fast you can process the data that way. So what are you really doing? You're setting up a wavelength zone through the management console. You'll create your subnets and your route tables and your security groups. You'll deploy whatever your compute is, like your virtual machines, EC2 instance, EKS, what have you, Lambda functions. You'll configure your networking, and you'll monitor and optimize. So optimize for low latency. Make sure you've got good security and compliance. You figure out your costs, use the cost explorer, that sort of thing. Make sure you use the right size virtual machines. So think about that. So think of it this way in your mind. The phone providers themselves have their data centers, right? And they have all their 5G antennas, and they've got all their switches that route back to their main networks. There's already a data center there. Verizon has them all over the place. AWS has them all over the place. If you could put AWS compute in the data center that's close to you, which could be owned by a phone company or something where your systems are, now you're going to have reduced latency and better performance, and everybody is happy. So I said I would stop at 5:20. So does anybody have any other questions on the things that we just covered? If not, apologies for keeping you a few minutes late, but it may most likely going to give you Friday off. And we may have some fun, surprising announcements as well. Okay, it doesn't look like there's any questions. So everyone, thank you so much for coming. If you've had a good time, you're learning something, maybe hit the bell, subscribe to be informed and hit the bell and subscribe to be informed of new videos. Give the video a like. Signals the algorithm to send this to more people. And I will see you all tomorrow at exactly 2 p.m. Eastern Time. I look forward to seeing you all. And let's get geeky with more AWS Solutions Architect Associate Training. And this concludes day 6 of our SAA C-3 preparation for the AWS Solutions Architect certification in 2024.